కౌన్సిలింగ్ స్టూడెంట్స్ ఇలా ఉన్నాయి. I'll get it posted now. Please give me a sheet. Give me a sheet. Mic off this. Mic off this.
Mic off చేయాలి.
వాటర్ ఏదో కూడా ఆఫ్
I am taking it now. They are not serving within
ఇప్పుడు చూడు. ఓకే ఆఫ్ చేస్తున్నాం అంతే.
We will begin our technical session with a lecture by Dr. G. Narahari Shastri, Director, CSIR, Northeast Institute of Science and Technology, Assam. Sir is online now, and this session will be chaired by Professor Nirmal Lohia Sir, Emeritus, University of Rajasthan, Jaipur, and Dr. K. Tangaraj Sir, Director, CDFT from Hyderabad. Tangaraj Sir will join us shortly. Meanwhile, I request Professor Nirmal Lohia Sir to please take over the session.
Sorry, I didn't hear.
Sir, you will be chairing this session, and we have 4 lectures in this session. Dr. Narahari Shastri, sir is online. He will be starting the session, sir.
Excuse me. This is from Shastri Research Group. So we will join in within 2-3 minutes.
Okay, sir. Okay, we will wait for sir to join us.
Yeah, sure.
It's a pleasure for us to inform that Dr. G. Narahari Shastri sir is also the outgoing president of bioclues.org. Sir will be joining us in the next 2-3 minutes. Yes. Then I will call.
Hello, good morning.
Very good morning, sir. We are beginning our day 3 of the international conference with your session, and we have Professor Nirmal Lohia sir to chair this technical session.
Good morning, Sugu.
Good morning, sir.
Sir, were you able to hear me?
Yes, very clearly.
Yeah, sir, I am handing over the session to Professor Nirmal Lohia sir.
So it is a great pleasure to invite Professor Dr. G. Narahari Shastri, and he is going to speak on a very important aspect and topic about role of mathematics, statistics and computers on the evolution of our understanding on the disease, health and drugs. And without taking more time, I would request Professor Shastri to please give the presentation. Thank you so much.
Thank you very much. Am I audible?
Yes.
My slides visible?
Yes, certainly.
So, Professor Lohia, thank you very much for your kind words of introduction. And I am extremely sorry that I am missing this opportunity to visit the Vijnan University, which I planned to be there for many months. But just about last week, I had to have some emergency and then could not travel. And disappointing the entire team of Bioclues and Invix, and I myself am missing this. So, today's talk is on a general reflection. It's not a very serious talk, but it's an important talk on how we try to look at the disease, health, and drug discovery, and how theory, modeling, or mathematics or computation will help us in our understanding and how our understanding is evolving over a period of time. So, I just wanted to say that if you look at drug discovery, there are ways to design molecules with desired properties, and there are so many methods of that. Adaptation of rigorous computational procedure is very, very important, and I don't have to stress that. But what is rigorous and what is not rigorous depends on so many factors. But construction of a model which captures the comprehensive physical picture is essential. While it's important to have a rigorous method, it's essential to have a model which captures the comprehensive picture. And most importantly, you cannot have either a computation or a mathematical modeling or an experiment which stands on its own. We have to develop an interplay between theory and experiment. Let's look at health. And there are different aspects in health, like age, physical health, mental health, environmental factors, nutrition, and geographical region and population will also be responsible for defining who is healthy and who is not healthy. I just wanted to say that according to the WHO definition, health is a complete physical, mental, and social well-being, and not merely the absence of disease or infirmity. I will try to talk about infirmity during the next few slides, but currently they are adding two more dimensions to it. I can understand physical, mental, social well-being also I understand, but what people have realized that emotional and spiritual well-being is also being added. So, if a person is healthy or not does not depend on whether they are disease-free or whether they are weak. They will have to have holistic health with physical, mental, social, emotional, and spiritual. So, if you look at the aging as a process, we have people at different ages, and their health at different ages can be defined with different parameters. If a 20-year-old cannot run 5 kilometers with a reasonable speed, probably we say that he is not very healthy. But that does not apply to either a 2-year-old or a 80-year-old. So one has to consider the aging as also a determinant. So we have two things like immunity and inflammation, which are very specific to the individual. There are genetic factors, physical, environmental, nutrition and lifestyle, and cognitive factors. So it's extremely difficult to have a single measure to tell whether a person is healthy or not, or a treatment which can be recommended based on the symptoms at least. When you look at computation or mathematics, we can go back to the most fundamental principles that any realistic model has to be modeled by some mathematical equations. But according to quantum mechanics, reality can only be measured to the limit derived by Heisenberg. We attempt to model the reality of an analog world with digital computers. Hence our models, however accurate, will only be depicting the epistemological reality but not ontological reality. There is an essential difference between the reality and what we observe. And if you go a little bit deeper, the very process of observation will perturb the system. So you can never observe a realistic model according to pure quantum mechanics. In other words, however honest are our models will always be approximate. The question is how approximate they are. But is it possible to just leave that these are approximate? I think anything that manifests in nature has to be a cost. So the innate motivation of any model has been to mimic the objective reality as closely as it can be perceived. So this is the first approach. So I just wanted to talk about the disease or infirmity. This definition is the WHO definition, and then two more dimensions like emotional and spiritual well-being are added. Why do somebody feel that they are not healthy? Because they feel that they are having something called frailty, which is a decline in physiological reserve and function across multi-organ systems. So what are the phenotypes of this? Probably unintentional weight loss, weakness, exhaustion, slowed walking speed, low levels of physical activity. So when these things are there, you try to measure with some of the parameters that one has, whether this person has fever or not fever, whether they have cold, or what is their blood pressure, what is their pulse rate, what is the sugar level, whatever, thyroid, all the tests that one does. But the correlation between the phenotype of frailty and the biochemical parameters that one uses to measure a person is healthy or not are always, to say the least, they are not leading. So there is something which is more profound. So if you look at the pathogenesis of frailty syndrome, there is etiological factors like aging, which I discussed before, or genetics, lifestyle, or environment, and how this frailty will manifest when a person is having a particular disease. That's very important. So what are the potential mechanisms? As I said, inflammation and immunity. So chronic inflammation, the cytokines, immune cells, the interleukins, there are different pathways or intermediary system, and you also have these phenotypes and health outcomes, or people may fall, disability, dependency, and etc. So if you look at methods to assess the nutritional status, there are different methods. There are anthropometric measurements. Nutritional means you have micronutrients and macronutrients, and you have biochemical estimation, or you have dietary patterns for diet. And there is a huge mismatch or not a strong correlation between these parameters. You may have an excellent anthropometric parameters, BMI is good, and now there is a trace for size 0, whatever muscle, but probably the biochemical estimate that is not good. Somebody may be obese and fat and everything, and their biochemical estimates are better. So there are different dietary patterns and the diet service, and it's extremely important for somebody to put all these things to mathematics and then come up with a way of understanding. So if you look at factors which connect rare diseases, metabolic disorders, lifestyle diseases, infectious diseases, I don't have to explain for this crowd what is a rare disease. What is a rare disease is not rare anymore, because the number of people are increasing with the rare diseases, and usually if one person in 200,000 people have a disease, that is called a rare disease. And these rare diseases usually have a problem because you don't have enough market, and you have to have a specialized drugs, and there are lots of problems, and actually many people from third world countries are going to the developed countries just to get the treatment for some of these rare diseases, because the treatment protocols are not available in the underdeveloped. So you have metabolic disorders, lifestyle diseases, and infectious diseases, and they have something to do with lifestyle, with the richness. But we all know when COVID struck, it is the rich countries which felt the shock more than a poor countries like Africa. I am not saying that COVID was not affecting them, but the shock that the COVID has given to a rich country like United States or Europe is much stronger compared to the jolt that it gave to Africa, or for that matter, I think we had a very strong dose in second wave. So we have to take this into consideration. While the modern medicine has developed in the past that if a particular person has a symptom or detected with a particular disease, they will have to use a particular medicine. And it doesn't matter for this modern medicine what is the genetic or what is an individual. So, individual person, and sometimes they don't even bother whether a particular individual is having some problem or a comorbidity. So, precision medicine and personalized medicine has become very important and becomes very strong in the coming days. The P4 is predictive, preventive, personalized, participatory. You can also add one or two more P's. So, basically, we have lifestyle, genetics, and most importantly, the gut microbiome. Because it's easy to measure gut microbiome, but people are also saying that the microbiome that is there in the organism is very important. All of you probably know that in human beings, the number of cells of microbes are 3 to 4 times more than the human cells. About 15 years back, we used to say that there's 10 times more, but there's a course correction. Now, it's very clear that microbial cells are 3 to 4 times more. However, we have to realize that the volume that is occupied by these microbes are much smaller than human. Because about 15 years back, I used to really wonder, are we really human or we are a conglomeration of the bacteria? So it's extremely important for us to understand things if you want to really address this drug discovery or other aspects. I'm sorry, I did not know that this slide is there. So this post-COVID WHO health has included emotional and spiritual well-being. I always feel that health is very important. Disease is a small perturbation to that. So, considering the three parameters, physical, mental and social, health is equal to what is the perturbation that is there in the physical well-being, mental well-being and social well-being. We can also add EW and SW as emotional well-being and spiritual well-being. And we have to see that disease is different from sickness. Sickness is different from illness. Illness is different from malady. So, if a clear-cut disease is there, you can treat. But sometimes sickness and illness or malady, they cannot be treated unless you understand the root cause. Probably you need to have the roots in mental wellness or social wellness or emotional or spiritual wellness. Because somebody feels very sick if they lose a near and dear. So whatever therapeutics that you use, it might not go. Probably if they are exposed to something which take care of their mental wellness, they will go out. So it's extremely important for us to subject our understanding without any fear to mathematics. So if you look at health, the physical, mental and social well-being, we can try to have different parameters, what are they, and then try to see that how you can develop a mathematical model for disease and health and how this can be possible. So there is a lot of scope for big data, artificial intelligence and machine learning in this area because every individual is different. The amount of information that we have is different. And we also have to see that aging and other factors are there. So a data-driven structural biology, molecular modeling, understanding the pathophysiology and understanding the degenerative nature of the diseases and disease progression, disease onset are extremely important aspects for us to consider before we can look into drug discovery or computational biology or applications of bioinformatics or next generation sequencing models for either health or for disease. So if you look at the disease pathophysiology, there are various factors that are there. Metabolic pathways, which is very straightforward. There are organisms and the gene expressions, and we have the protein targets, and we have epigenetic changes, and we need to have a very good understanding on many of these factors. And recently, as I said, this gut microbiota has become very important, and disease relationship is very important, because once you have a disease, how do you treat with that? For a normal person with a one disease, or with a person with a comorbid. And when that is there, how gene-gene interactions and other things are taking place, this is also something which we have to consider. So, disease manifestation in any organism is inherently dependent on a number of factors, and unraveling the working strategy is extremely important. So now let's look at the drug discovery, which people are very, yesterday also I spent some time listening to people. They use bioinformatics, chemoinformatics, computational biology, machine learning, structure-based approaches, ligand-based approaches, QSAR. So many of these methods, so many of these computer programs are available. But one has to understand that if you look at a drug, an oral drug must be able to dissolve in water, but still it has to cross from the aqueous medium to an organic medium, because it has to, in most of the cases, cross the membrane, and when it is orally administered, it has to go through the gastrointestinal tract, which has a very strong variation in the pH from highly acidic to basic. So it has to, more importantly, survive the intestinal bacteria, cross membrane, survive the first pass mechanism. There are so many factors that are. And the selectivity, toxicity, bioavailability. A drug has to satisfy so many conditions. It need not be the most potent, not the most stable, not the best absorbed, not the least active, but the best balance. And also one has to see that how many of these factors are optimized. And if you are trying to look at only in a single dimension, it may be difficult for you to get the best drug. So there are different stages in drug discovery. Very early stage is just to take a active products, and currently we have many other factors which are coming from the second generation. But the current bottlenecks, we have to see that the costs are increasing. When somebody puts even 10 billion, I don't think that this is so high, but this is an estimate that somebody gives. And the time taken is very high, and we need to have partnerships with clinicians, pharma industries, research institutes, government, regulatory, funders. And we also have different challenges that are there in the drug development, especially from the regulator. And even if a drug is developed, there is no guarantee that that will survive, but there is a post-market surveillance and there is a phase 4 clinical trials. But somebody like me, who is in an academic institute, you can use, and then you can publish lots of papers, and if anybody is publishing papers in drug discovery, probably they are doing a lot of useless research. Because if anything useful, you don't publish, right? That's what the company and other people will say. But this is important for you to work in academics, but also it's important for you to realize the limitations. For example, if you look at the drug product profile, delivery route, there are different delivery routes, they are important. Drug-drug interactions are important. Differentiation from the current therapy, what is the novelty, what is the safety, cost, efficacy, dosing frequency, cost of the drugs, risk of misuse, this is very important. Actually, many of the drug industries are having ingredients or even drugs which might be misused for a different purpose. For example, many of the cough syrups are very addictive. Once a person is taking the cough syrup, they would like to take it because they are addicted to it. It's not that they want to alleviate it. And I have many other drugs which might be drugs in course for it from a different perspective. So, side effects are important, and safety in selected population, dose adjustments, and monitoring specialists, Actually, in specialist population, earlier we were using child and pregnant women and geriatric, old patients. But now there are a large number of these varieties are coming. For example, in post-operative care, if somebody has a post-COVID care, or patients which are predisposed with hypertension, or predisposed with diabetes, or with bone, people with thyroid problem, people with so many problems. When they get a particular disease, how do you treat them? These things are very important. And this is a famous drug development cycle where you can try to keep on spending money. This is zero money, you keep on spending, and after 5, 10, 15 years, you get a product, and when the product is launched, still you will keep on spending money before you gain the products. But most of the attempts will be buried in this valley of death, because only very few people will, very few candidates will eventually become drugs, and then they see that this is a success of business, and once there is a blockbuster drug, you can see that the profits will be good. So, for all this drug discovery, most of the people think that we need to have a software and a hardware. And hardware is you buy a computer, software you buy software. But when we started our PhD, we never got software, because software and programs are free almost. Those who developed, they were giving. But now, we have to see that what contributes to better understanding and comprehension and analyzing computational drug discovery results. We have an input and an output, or you can have an input and you have several outputs and then you try to analyze all of them, or computer-aided drug design. It is actually identify the cause based on pain and symptoms to treat the disease, which was need-based. Now, we are not realizing that everybody goes to a doctor and find out what disease that they have, what are the drugs that one has to use. And if somebody says that they are having a disease, they are very happy that this disease is there. If somebody says that they don't have a disease, there are also some people are very happy, but some of them are not. They will go to some doctor to just tell them that you have a funny disease, and you try to diagnose with modern testing facilities and find out what is the problem, and then start taking it. But I think slowly we are going towards a personalized health, focusing disease symptoms and progression at individual level. So you will have to understand your own disease progression with all your background, and it's not possible for you to just adopt a particular protocol that is developed for a general population. So for that, I feel it's extremely important to develop a mindset for software development in our country. So for software development, we have different tools, but idea is important, and you have to ideate, formulate, collaborate, develop. And once you develop, you have to assess, and then you will have to share the problem. You will have to make some plan. We try to develop a software, and this software initially is aimed at analyzing what are the properties that a molecule has, whether it can be a drug, or whether it can be, if it is a drug, against which disease, so on and so forth. So this is started almost in 2004 as an idea, but it took almost 7-8 years before we started working, and lots of people have started working, and then we published some papers, and still it's going on. I don't think that this is an NPDS, which is a disease specific drug portal. Mr. Chairman, how much time I have? Another 4 or 5 minutes? Or?
Please go on, you have another 5 minutes to go.
Okay. So, we choose the Galaxy platform for the computational drug discovery because the Galaxy is by definition open source. This is a community-led development activity, and data analysis can be done very well, and this is available for anybody. And it's also depends on accessibility, reproducibility, and more importantly, transparency. So we are developing this with different modules like data library, data processing, data analysis, and those of you who might know that we have a disease-dependent modules and disease-independent modules in this. I will try to actually say that in Jorhat, we have a group which is completely devoted to the software development, and we are also having different areas of research. And I just wanted to spend next 2-3 minutes on the scope in the Northeast India because I am representing Jorhat. There is a lot of biodiversity, geodiversity, and there are seismic hazards. And the big data analysis, simulation, and interpretation on the geodiversity with AI and ML has lots of opportunities in many areas in general in Northeast India. So this is a program that we have conducted, Summer Research Training Program. Just to tell you that if you have a strong will to do something, you can always do it. This was done in 2020 when the whole country was under pandemic. We started to have a program, and within 10 days we got more than 16,000 applications. And we tried to give the Summer Research Training Program to everybody with 850 mentors, and eminent scientist lectures were given who and who in India. And there were several competitions, and everybody has given a mentor. And this was pan-India, across different places, even from all the parts of the country they have participated. And we have a 1 million website visitors within 2 months of this. So the data science and advanced computing and data science division in Jorhat, we are not only developing this software, but we are also collaborating with people who are working on infectious diseases, floriculture and aroma mission, biotechnology, petroleum research, material science. Whatever may be the area, the computation, modeling, artificial intelligence and machine learning is very important. If some of you are interested, this is again a program that was conducted in 2020. This one are SRTP. All the lectures and video lectures are available. I think Prash and Subbu also gave some lectures, if I remember. So there are lectures which were given based on theory and computational methods. One vertical, focus on algorithm and method development as second vertical, and third vertical is on hands-on sessions on open source and commercials. So you can still access these things, they are available on the net. So there are different activities that are going on in CSIR NIST. And I am very happy if someone would like to come and then visit us. Welcome to this. This is how it looks. And I don't do any work. They will just try to talk about work that is done by this group of people. These are mostly people working in advanced computing and data science division. And when somebody, if they want to entertain, they will also appear in these types of Northeastern presses. And once again, I thank all the organizers for giving me this opportunity. And it's wonderful to work with BioClues with lots of enthusiasm by Prash and colleagues. And I hope that this particular BioClues will reach higher heights in the next 2 years. And I will be very happy if anyone wants to ask some questions. Thank you very much.
Thank you so much for a wonderful presentation. In fact, it is a rare opportunity to listen to such an excellent talk. Compliments to Professor Sastry for a wonderful presentation. And his presentation is open in case any comments anybody would like to offer or any question. Please have the right and please identify yourself and then ask the question.
Good morning,
I
sir.
can identify you.
Yeah.
Sir, good morning, sir. Yeah. So, before asking a question, I would like to thank you for being an excellent president for the BioClues for the last 2 years, and under your stewardship, we have grown leaps and bounds. And everyone here, please give a big hand to him. Thank you, Lord.
So it's just a kind of a big compliment to our own Narahari Shastri sir. In fact, he has been a big beacon of hope. We cannot really thank him in just few words like this. We all core members are here, giving him a kind of a standing ovation, for the human service that he has done. In fact, for BioClues, I cannot say that, our life membership were very meager. But after he came, within 1 year, we got, 320 new life members. Can you imagine? So it's almost one new life member every day. So, and the kind of vision that he has set up, for making, galaxy community and other things is really impeccable. Thank you so much, sir. You have been truly inspirational for all of us. Thank you so much.
Standing ovation.
Yeah, please. If I may just request everyone, to give.
And Professor Shastri, you made my task very difficult because after listening to such an eminent speaker and wonderful presentation, I do not know I am going to justify my So a big thank you, Professor Shastri, for a wonderful presentation.
Yeah, sir.
And
A question from you.
yeah, there is a question from the audience, please.
Hello sir, myself Ramnath Datta and I was in the CSA scientific team on the time. And I am now in Biotech board member. Sir, I have one question that you told about this AI, this medicine. So all is fine. So now it's working also. So we are having another aspect is a nuclear medicine, right? And it's also based on this mathematics and statistics. So, sir, do you think that it will take place in few decades? Means how much assured we can that means what will be the probability rate with success of this nuclear medicine?
The proof of anything, the pudding is in eating, right? So there is a lot of potential, but it has to still to be tested. And this is going on for the last 2-3 decades. And in India also lots of people are working. And I strongly believe that there is definitely a strong room.
Thank you.
I am Professor Krupanidhi from Vignan University, sir. So here,
How are you?
yeah, fine. A few doubts, sir. So you have given us a new term with which we are not familiar about the frailty syndrome, and the symptoms also you mentioned very well. But how to develop confidence in life? Those who develop confidence in life, they will be away from the frailty syndrome. That's what my intention is. The next question is, so plenty of anti-inflammatory drugs are coming. Those were the days we also used Voron, later some other drugs, later what is it called, Phenol Plus, now some other drugs are coming. Well, though after having done so much of extensive research and drug got released, and again they are going to become obsolete soon. As you are showing in our graph, there is a dip. So why it is so, why the companies are facing such a type of issues? These are the two things, sir. Thank you.
Excellent. Thanks a lot for asking very, very important questions. How do you develop confidence in life? If you are healthy, you will be confident. And health itself is defined as social, emotional, and spiritual health. So you have to be happy about yourself, and that will give you confidence. And when you have a physical and mental health, people have very clear definition. But the social health is, if your own colleague gets something, if you are very happy, then your health will improve. If anybody in the community gets something which is good for them, if you also share that as if you got it, you will be very happy. And emotional, you just have to see that how you are very happy emotionally, how you are satisfying that you are having a very healthy life. Emotional health is very, very important, and this will have to come from within. And the third aspect is the spiritual thing. When you get up in the morning, are you having good spirits? So I am not talking about the spirits in the after sunset. That's a different thing. But how enthusiastic you have in leading your life, and this is very important. And when you have the energy, you will be confident. When you have health, you are very confident. And this confidence will come from health and health. About the anti-inflammatory drug, actually immunity and inflammation is something that we will have to nourish. And this also comes not just by popping up the tablets which are required. If you have some allergen sitting, for example, you may be exposed to the pollen, or you may be exposed to some other thing, or you might have some food which has problem for allergen, inflammation and immunity compromising. But some of the known concepts that are there in our Indian traditional medicine could also be practiced. I try to tell three things. One is, whenever you have a problem, Lankanam Paramoksham. The people say that you just fast for some time, it will heal the problem. So this is something very important. And the second thing is, Ajirne Aharam Visham. If you eat something when your previously eaten food is not digested, it will become poison. And the third one, which we did not know much, is the Viruddha, that you try to take two different foods at the same time, that might have some problem. And also, there is a way that if you eat something more, you can have an antidote. For example, if you eat peanuts more, you will put jaggery, and in Andhra people know very much. So, what are the things that you will have to follow? For example, my grandmother used to say that if you have mangoes too much, you try to take buttermilk or curd. And if you have the sitafal, custard apple, you have to take water. And there is probably some logic in that. So, one of an eminent scientist and medical doctor, Padma Bhushan Awardee, Sanjay Trikhan, he was giving a talk in the Chandigarh Science Congress, where we gave back-to-back talks. He made a very important statement which will be remaining with me throughout my life. He says that health is a very, very close personal thing of an individual. Never ever outsource to other person. You will have to take care of your health. Never ever outsource to an individual, but definitely not to the doctor. You have to go to a doctor when there is a crisis. We also know that Vaidya Narayana Hari, we all have a lot of respect for doctor, but you cannot really depend on the doctor to take care of your health. You have to do everything that is possible from your point of view and take the help of the doctor to return. I think I sort of answered in a rather philosophically, not like a scientist. So, I hope it partially answered your question.
I think listening to Professor Sastry, it appears that we keep on listening, and he narrates things in such a beautiful manner, and well said that if you have a positive attitude to things, you are healthy. And this is the summary of everything. So a big thank you, Professor Sastry, for a wonderful presentation.
Thank you, sir. You have yet again proved that science is also a philosophy.
Yes.
Thank you. Thank you, sir. Moving ahead,
I just wanted to say that if someone wanted to have a lot of fun, I recommend that they have to read a book, The Biology of Belief by Bruce Lipton. Some of you, I always feel very much encouraged when I read this book.
Okay, sir. Sure, sir. Thank you. Thank you, sir. Thank you. Moving ahead, I have two important announcements to make before we listen to Lohia sir's session. All the chairs who have taken care of the oral and poster presentations, you are please requested to hand over the reports to Dr. Anil Kumar. And the other announcement is, in the tea break, I want all the delegates who are presenting posters, please put up your posters in Convocation Hall. The judgment will begin after the tea break. So during the tea break, you are requested to please go and put up your posters, those who did not put it up so far. Yeah, and please do not leave the hall while the sessions are going on. During the tea break, you can quickly go and put up your posters. And now I think I'm extremely privileged to introduce Lohia sir because his co-chair Tangaraj sir is not here yet. So we will now have a technical session by Professor Nirmal K. Lohia sir, University of Rajasthan, Jaipur. He is going to speak on discovery of papaya seed products as suitable formulation for male contraception. Sir, over to you.
I think Professor Sastry has mentioned that at some stage of his presentation that using natural products may also contribute to good health. And he also mentioned that primarily the root cause of everything is the uncontrolled population. So I thought that I will share with this august audience some of the part of the work which we have been pursuing, developing natural contraceptive. And in that sense, I feel that using the papaya seeds is the source of contraception. So if you look into this slide, you will realize that how big is the problem. We see that about 8 million people, world population is, as on today, is the scenario. And if we see that all continents of the globe are richly contributing to this. And if we talk about specifically of the East Asia, South Asia or Asian continent, we'll find that the contribution to this 8 million is tremendous. If we see only this part, we feel that this is the projection in times to come, somewhere during 2050, what is going to be the scenario. And we feel that our country, this is being reflected, maybe not very recent data, but in 2017, what is the population like, and in times to come, what it is going to be. As on today, we are behind China in terms of population, and in projection, we are going to surpass China population. And looking at several other countries, we feel that projections are there where almost all countries will add to its population over the time, but interestingly, China will have control over the growing population from the projections. Now, if you go ahead in this, lack of family planning, half of the pregnancies in India are unintended. How big is the issue? I will be talking only on contraception, but related reproductive health issues or family planning issues would also be highlighted, where we see that about such a big, about intended 52, almost unintended almost similar 48%, and of which we find 33% end in abortion. So you can appreciate that unintended pregnancies resulting into unintended abortions and so on and so forth. So all this happens because a large number of people in our country are illiterate or unaware of, and because of that we find that the various advantages of family planning and the ill effects of overpopulation is not known. And we think that it is probably God's gift, keep on producing, and those people who are illiterate, they don't believe in having the family planning to use. If you look into this family planning sustainable development goals, we see that all the things mentioned here, the quality education, the zero hunger, the good health, and so on and so forth, all these things are related to limited family or using the family planning procedures. So looking at and highlighting problems with the uncontrolled overpopulation, we feel that one of the options to take care of this is the contraception. And from that point of view, that there are several such options available for the female partners, but at the same time, when we go for the male partner, we find there are very limited choices. So as the student of reproductive biology, when we look into this, that can we address the issue of limited choices for the male? And from that angle, we see that if we look into this, about 12% people use IUCD, others they are methods, and out of all these things, very limited people use vasectomy and also the male condom. So we have a very limited people and limited choices for the male partner to use the means of contraceptive methods. And here you see that societal gender norms tend to associate contraception, reproduction as being a woman's issue. Even today, we have in the society, maybe because of the male dominance or maybe other factors, we feel that it is the responsibility of the female partner and very little to contribute by the male. And here we see the historically lack of research into male contraception and a perceived lack of market interest has deterred the pharmaceutical companies from investing. Because any pharma industry would like to invest where there is a return. And if we find that there is an intervention only one time, less people to use, they may not get return. So we say that it's difficult to develop adequate contraceptive for the male. We have almost 11 contraceptives available for the female partner, whereas the male is having only 2. Why this is happening? If we see that while developing a contraceptive method, one has to look into whether do it work, are they safe, very important, because contraceptives are used by healthy people and used for very long time. So one has to see this very important aspect, and are they available? At times not. And then are they affordable? Because for long time use, it should be affordable to people. And do they protect against sexually transmitted diseases, which has been in the recent past has been realized that that also is very important aspect, and expectations for the users whether it has a protection against IUCD and STD, so on and so forth. So we looked into this, that what are the sites where you can target, and world over you see that efforts are ongoing. Many of the pharma industries are trying to develop a affordable and one-time use of the contraceptives. And the targets, when we look into this, we'll find the testes is one, the epididymis, maybe audience, some of the people might not have a background about the male reproductive system, and we see that these are the part of the male reproductive system where we can target any approach for developing a contraceptive. And from that point of view, we see that I will quickly go through some of the slides which are important from the point of view of giving you an update about the current scenario and in the recent past what efforts have been made, and then where we are today in terms of developing male contraceptive. You would be surprised that for last more than 4 decades people have been trying, and including our group, and we have been targeting various approaches, and we found that how difficult it is. At times it is effective, but at the same time it has side effects. At times we can control side effects, but long-term administration is a problem. I will quickly go through some of them and then come to primarily as to how the carica papacy best contraceptive, after extensive investigation, we have come to a stage of a formulation which we look forward that it is going to be a orally effective long-term male contraceptive. So here we see these are the things, I will go, these are the methods available, and available methods are very limited, and the efforts made includes the hormonal methods, wasp-based methods, and herbal methods. And the limitations are that it has a lack of uniformity, and drug delivery is a challenge for a long time period. And issue of reversibility is a big issue in wasp-based method. I will just give you a brief about this, that wasp-based method from our country, what we call is a RISU, reversible inhibition of sperm under guidance, is the one formulation which has gone and completed phase 3 clinical trials. And this is considered to be the only approach worldwide from our country where we have cleared phase 3 clinical trials awaiting the approval of the drug regulatory agency, Drug Control General of India, to go for mass application. And do hope that this is one time intravaginal injection will take care for a longer period, where our group was involved in specifically addressing the issue of reversibility, because we see that the vasectomy or no scalpel vasectomy also serve the same purpose, but the challenge is that can we have reversibility as and when it is required, and that is a big challenge. And from that point of view, the wasp-based method issue, which we have been investigating for last more than a decade or so, we found that yes, there is a possibility. It is being done in rat, rabbit, monkey, human, all models. And this not for today to give a speech on this, but just to make a mention, and then I will be restricting only to the hormonal approaches. Now, if we talk of the hormone, talk of the natural products, we see that natural products having several advantages, like it is a natural in origin, orally bioactive, cost-effective, long follicle history behind it, low toxicity, non-steroidal, mostly orally effective. So several of these formulations are available which have been used, and efforts have been made over the time extensively, and I will give in few slides what efforts have been made starting from WHO task force, and during this whole period a lot of efforts were done. Several of the formulations were identified, and several of the plants were identified, and finally it reached a clinical evaluation in 9, and today if we see the status, we see a question mark. And why question mark, I will tell you in few slides. Now we talk about the ICMR task force. It had task force starting as early in the mid-60s, and several efforts again were made, and we found that several organizations, agencies were involved, and the several plants were identified, and these were the few plants which they found that yes, can have a future. But the Central Drug Research Institute CDRI also did same thing, and out of 3,300 plants screened, they could only identify 67, of which we find outcome is in the form of the concept. The whole CDRI, if you ask them the question, for last several decades, what is the outcome? We see the outcome is in the form of a female contraceptive we call concept. The other agencies involved, like CIPLA, Glaxo, Upjohn, so many organizations, pharma industries, so many government, CSIR, DBT, ICR organizations involved, and thus so far promising outcome, we just look forward. So the plants which have been found to be the identified the lead plants, these were some of the lead plants which have been identified, but unfortunate part is that when we look into their future, we'll find that initially they appear to be promising, but later on none of them have gone to, only few to clinical trial, and as on today we don't find any male-based approach which can be acceptable. And in that context, the Carica papaya, whatever has been done, I will just share with this audience. So the gossip probably it is a historical background, but we see that the gossypol is one formulation and triptyllium wilfordi is another formulation. We did work on these two things which are Chinese based formulations, but unfortunately the hypokalemia based in gossypol did not allow to go further, though several clinical trials were conducted, and same is true with triptyllium wilfordi, where we see that the genotoxicity and the compromise with the immunosuppression that did not result into further investigation, and these were some of the formulations which were done at some time but did not proceed further. I think it got stuck up somewhere. Oh, okay. So it started, or maybe it gets tired after some time. So Carica papaya is one which we see that it has multiple biological properties. And you talk of anything, you will find yes, it is useful. Like it has been found to be anti-cancerous, anti-diarrhea, and so many things. And here the leaves anti-dengue activity, anti-malaria, antibacterial, anti-cancer activity. So the parts of this plant have been found to have various biological activities. And yesterday we were talking about, we said that even during the period of the COVID-19, several people found that the papaya products can be useful for addressing the activity. Very extensive studies were done. We started initially with what you call as the crude formulations of the seeds of papaya, and these crude formulations will start from aqueous, methanol, methyl, chloroform, so many. And after that we will find that which is a better formulation, find chloroform extract was relatively better formulation. So then we worked on this further with the column chromatography, and then keep on go for the further fractionations. And finally, I would cut short, say that there were the compounds like MCP1, MCP2, ECP1, ECP2. These were the 4 compounds which we found that are promising. And of all these 4, we find MCP1 is more effective. So we carried out lot of studies with MCP1. And quickly, because of the time constraint, I'll just give you highlights of how we proceeded and what have been the outcome of this and what is the current scenario. We see that the chloroform extract and the benzene chromophyll fraction, you will get sometimes you feel that several fractions and sub-fractions have been used and very extensively investigated in 3 animal models starting from rat, rabbit and monkey. And we thought it was essential to do it because our target was to see that can we go for clinical trials, and that should be possible only when we have one rodent model, one legomorph and one non-human primate model. Then only the drug regulatory agencies would permit for going for clinical trials. So these formulations were done. What I would like to stress is that very interestingly, the mode of action of the formulation was different. And this you may observe that either it inhibits the sperm motility or it results into agiospermia. This is a big issue, and this was done all through where we see the further extension in ethyl states of fractions. Again, was done in rat, rabbit, monkey, and isolation of MCP1 and MCP-ECP1 again done in all these animal models. And MCP1 will see the rat model sperm motility inhibition takes place, langur monkey sperm motility inhibition takes place at a particular duration of treatment. I think this is the first study where any plant-based formulation has been used as long as 365 days. Continuously oral treatment, which we found that it keeps on maintaining good health of the animals in terms of several of the parameters which I am going to project, and at the same time it either inhibits the sperm motility or simultaneously it results into decrease in the sperm count. And these are the 2 very important aspects for contraceptive. And then we examine that if we talk about the rat and the rabbit, we found that mating experiments were the proof of the contraceptive efficacy. But we talk about the monkeys, we found it was difficult to perform mating experiment. So our basis was the sperm functional test. And the sperm functional tests are again the WHO approved approach which are being done. In our laboratory we have, I think, unique facility where rat, rabbit, monkey, human. So we have been pursuing research on animal models as well as human. Human, I said that we have been conducting clinical trials with research, which I am not going to talk today, but it is there. And then we see that characterization of MCP1. It was important because when we were giving presentation in Ministry of Health and Family Welfare, Government of India, it was said that don't go for further characterization, you straight away go for the clinical trials. And that was the time we realized that there are several occasions where plant-based formulations effective in one situation may not be in another situation. So this type of variations in the effectiveness of the plant-based product prompted us that we should go a formulation which should not have this type of limitation. So here we see that as the NMR spectroscopy, IR spectroscopy, mass spectroscopy, gas chromatography, all these things were done. We had limitations of the infrastructure facilities. So what we did is we took help of several of other organizations, including the Central Drug Research Institutions, where we did mass spectroscopy. Then we did the GCFID chromatogram from Novartis Pharma, got in collaboration with this, which they agreed to do it for us. And then we have NMR facility at again Central Drug Research Institute now. And then this is a National Institute of Ayurveda in Jaipur, which agreed to process our sample for HPLC for MCP1. And then this is the HPLC analysis being done at again National Institute of Ayurveda. And finally we could come out with this, that this is the long chain fatty acids which are primarily in the form of oleic acid, linoleic acid, palmitic acids, they are contributing to this. So isolated compounds MCP1, we found that how it acts. Sperm count during the period, as I said, as long as 360 days it is being investigated. And then we see the sperm motility inhibition is there. So sperm motility inhibition also is the criteria to assess the fertilizing ability, and the sperm viability from and other parameters, they are the toxicities. I will only restrict to the presentation in a non-human primate model, and I have given you summary of observations using various formulations. When I am done with the time, please just give me a few 5 minutes. Time passes very fast, so when I see that, I will only give highlights of it. Okay. So this is the animal model on which we have been working, and we are known for langur monkey. This is the breast bites, antillus, and langur monkey, and this has been gone to all levels, including WHO, where our findings and this have been very well acknowledged using this animal model. We have used this animal model not only for this study which I am giving a presentation here, but several other things like the research I mentioned, like the combination formulations. The first time using from our group, that is in 1983 as a career award program, where the formulations were anti-androgen combination with the androgen formulation, could it be used? And we found that again a long-term studies were conducted, and we found it is very, very effective. But only thing is that monitoring, only thing is that long-term administration of androgen or anti-androgen based drug that limited us. So anyway, but I will go quickly because of the time. I see that interestingly, when we talk about the, I don't know from the back whether you can appreciate the slide, but when you see, we will find that the treatment schedule, and this is the langur monkey were treated with a particular formulation, and we found that after a particular time of treatment, 30 days, 60 days, 90 days, as long as 360 days, we continued our treatment, and we found that this is the sperm concentration resulting into azoospermia is a terminology where the sperm concentration comes to zero. The sperm motility inhibition is there, and this is being indicated. Then we go the sperm motility with another formulation methanol subfractions, and then we have done sperm concentration million with the isolated compound the MCP1. Here interesting is that it has effects both in lowering of the sperm count and as well as inhibiting sperm motility. So you find that over the time, only one out of these animals found that it reached to almost oligospermia, but the rest of the things will keep on, there is a decline in the sperm count. What is interesting is that we found that as early as 30 days, we found sperm motility inhibition is perfect using the sperm motility parameter. Clinical toxicity, just I will go slide projection, that this is very important because the drug regulatory agencies would give approval for clinical trials. We have acute oral toxicity, so many in rodent models, chronic rodent toxicity, carcinogenicity, reproduction, development toxicity in rodents, and all these things have been done. And the evaluation of skeletal malformations have been done. The spermatogonial chromosome aberrations tests have been done, and we find that using the what you call the negative control and positive control, you can appreciate that very distinctly giving the idea to how and the spermatogonial chromosome aberration test has been done, and since it was required to be done in 2 models, we did in rabbit as well, and then we found dominant lethal tests have been done and rodent dominant tests is being done. Now I would like to come to this thing that what was important is that MCP1 was very effective in terms of oral administration, but at the same time I will take 2 more minutes, sir. 2 minutes, okay? So what was important for us was to see can we have a formulation using what you call a nanoparticle based drug delivery system. And here what we have done is the development and characterization of MCP1 loaded methoxypolyethyl glycol polylactic acid polymeric nanomicelles and reduce the dose and enhance the contraceptive efficacy. This was our target. And the meaning is that this we thought that if it is acceptable, maybe we can go for clinical trial with this formulation in times to come. So this is the formulation in a summary which we have been able to develop. A long procedure is there, but we just summarize. And this has been done with the dynamic light scattering, the scanning electron microscopy, transmission electron microscopy, and the formulations where all these things have undergone the identification and characterization of the formulation, same time, and this has also been done in extensive manner. And this is the protocol which is being used for missiles. And we found that the coda-epidermal sperm count and all that being done in extensive manner. And the morphology of the coda-epidermal spermatogenition were also evaluated periodically. And this is the indication. And what highlight I would like to give is here that we see that these were the 2 groups where we use the MCP1 without micelles, and with both of them found that are effective, but then the drug load with the micelles was much lesser, and that's why we say that yes, this can be a formulation for times to come, and we can think of using the this as a for future of our clinical trials. So these were the studies being conducted, external morphology, and these are the different groups. We found that even this is very important because first one F1 generation, F2 generations, how it affects, to what extent it affects, all these toxicological data have to be presented, and these data are important for getting approval from the DCGI. So we have done extensive all these things and available in the skeletal evaluation morphologies, and this is the highlight where I just want to say that yes, we see that the MCP1 Carica papaya encapsulated with polymeric nanomicelles will open a new pathway of delivery of drug for contraceptive study. And a detailed long-term study on non-human primate, because this has not been done so far in monkey studies. These are the observations being based in rat, but we feel that yes, it can also be there. And to conclude the presentation, I would say that the extensive research findings are suggestive of taking MCP1 formulation with nanoparticles based drug delivery system for initiation of clinical trials, and we look forward for a positive outcome in near future. Thank you so much for
great work, Professor Lohia. The country needs it because this is one problem we have been facing last hundreds of years, and especially last 50 years. I have two simple questions. What happened that millions of rupees we spent through Professor G.P. Talwar's contraceptive vaccine and Dr. Professor Guha's thing, and you never mentioned even one word.
Sorry, I did, please, very rightly raise the issue. We all are aware about Professor G.P. Talwar's contribution, and we have been collaborating with Professor G.P. Talwar. We have been collaborating with Professor Guha, and we have several publications as a collaborating scientist. First thing, mentioning about Professor G.P. Talwar, you would be very pleased to learn that I have been associated from the very beginning when beta HCG based formulations were done, and initial period where studies were conducted found to be very good, and it had cleared phase 1, phase 2 clinical trials. But then there was certain stage where they wanted that unless there is a specific level of antibodies available, then the contraceptive may not be effective. And that was the stage where he had to move from NII, National Institute of Immunology, to RGCB, that is ICGB, what is that? International Center for Genetic Engineering and Biotechnology. What to be. And it is surprisingly when Dr. Om Prakash, my friend, he was there to look after this but could not carry further. To cut short the whole story, I was there as an Indo-US Joint Working Group expert, one of the experts, and the meeting held in Washington DC, and some US scientists raised this issue, what happened to Professor Talwar, and then some proposals came, and that was the time when it was felt by the group that why should we not reinitiate this study, and I was also one of the instruments in saying yes, it should go on, and I conveyed to Professor Talwar, it was again reinitiated, and now unfortunately when this is going on, there was some problem with the formulations, and that has been resolved as far as animal experimentation is concerned. This paper has again come in the journal with which the ISSRF is associated, like the Journal of Reproductive Healthcare and Medicine being published, but still the things are in between ICMR and the DCGI to give a clearance. This is the story of the Professor Talwar, and I am very sure that in times to come it will be. And then briefly I will say Professor Guha. Professor Guha is a very, very eminent, as we see Professor Talwar, and working on the research which has gone to all advanced stages, phase 1, phase 2, phase 3. And as I said that we were associated with, our center was one of the centers for phase 3 clinical trial conducting studies, and our group was there who addressed the issue of reversibility in monkey models. And then we have done extensive reversibility studies in rat, rabbit, monkey. And we have proved that even first F1 generation, F2 generation is perfect. But unfortunately again, Professor Guha, day before yesterday I had a talk with him, and I am in constant touch with him, and we see that again awaiting approval of DCGI in terms of having a mass application of research. And I do not know why, and yesterday to our esteemed chief guest of this event, I discussed with him, I said, what is going on? So he was also convinced that it should have a clearance from DCGI and it should go to mass application, and we look forward that it could be a replacement to available no scale for vasectomy. I would suggest this audience kindly click Lohia and K, and you will find large number of publications addressing the issue of reversibility with research. Thank you so much.
Sorry, I opened the wrong box. Anyway, thank you very much. It's a wonderful thing, and I wish you good luck with the MCP1. And I have another small question, only small question. You have all the three fatty acids.
Yes, yes.
Can we take the natural fatty acids of the same composition?
Yes.
And use it instead of going through the papaya?
No, we did it, but this could be only a partially part of it. But then the complexity of this thing, at times we may not be able to answer. We see, as has been said yesterday, day before yesterday, we were listening to various presentations, we will find that the body physiology is so complex that we may say that yes, it is effective, but there may be certain other, and if we look into totality, then we'll find, but we see that these long-term fatty acids do have contraceptives.
Thank you very much. I don't want to take your time because it is going to be hammer me.
That's your time now.
Yeah,
Sir,
I'm going to lose my time there.
I thank both Lohia sir and Ratnagiri sir, and now I think it's time Lohia sir introduces Ratnagiri sir because it's his session.
His presentation, and I need not introduce because his conversation has itself been a big introduction. And yesterday we found that what immense contribution he is making, and we provided, that, and I specifically requested him that could you please spare some tablets for me, and I don't hesitate in announcing that I am a prostate cancer patient. Nothing to worry about. And positivity, I use the word positivity. For last 10 years, it is a long time. And when I say that yes, if you have a positive approach, nothing to worry about. And I have that. And I look forward your all good wishes and from all of you that I keep working. And I said that...
I think we will give all our good wishes in a big round of applause. Please put your hands together.
And I will continue working. I go to department every day, even now, Monday to Saturday, and I have been working for last 15 years after my superannuation, and I have already announced that my body will go to SMS Medical College after I am no more, so that the scientists can use it for whatever way they want. Thank you so much.
Sir. We are really proud of you, and I think for our generation you are a great inspiration. Thank you.
So, please, okay, no, it is done. Let me do it. Pleasure to listen.
Hello, thank you. Good morning. The title of this presentation is Translational Research in IVD in India. What is translational research? What is IVD? Why we are doing it? What is a bench to bedside? Translational research is that we are translating something that already exists through the basic research. We have been doing basic research so much, so we think we finished the experiment. And you put the whole bottle. The basic researcher thinks the bottle is half full. Then the translational research guy thinks, hey, this bottle is not half full, this is half empty. What is the difference? It is not full bottle. When the full bottle comes, when you make the basic research into a product that can be used by a common man or any human being or an animal or whatever for the social purpose, then There is a meaning for the whole data. What we heard from the first talk, day before yesterday, Sir Richards, the same kind of title what he used, I am using the similar kind of thing, but I am talking more for the Indian purpose, how this basically set. We can translate and make a product into something useful for the community. From bench to bedside. What is this? This is aeroplanes traveling across the globe? No. These are the pathogens traveling across the globe. What is the difference between that? In the aeroplanes we go, what you need? A visa, a ticket, and also your luggage, and also you have to have where I am going to sit, in the first class or second class or last class, or standing by. Here, the pathogens, they do not need a visa, they don't discriminate, they can travel wherever they want, and there is no security check in the airport or borders, and there is no timeline. They can travel anytime. When they can restrict what we have seen between 2019 and 21, where regarding the COVID, it started traveling from, I don't want to talk, you know, from China to all over the world. Nobody stopped it. We all have gone through it. Now you know. Now, we have so many diseases. For that, One Health is the word recently we are using, and also zoonosis or zoonotic diseases. What are those? They travel from human to animal, animal to human. They can affect the animals as well as human. This is important because we are social animals. Especially in India, 80% of the people live in the villages. They live with the animals along with them. Not only cattle and sheep and goat and your poultry, but also you have pet dogs, cats and street dogs. So we all live with them, and those diseases that affect them, they can also affect us. As soon as your dog comes, you kiss it because it is your inside living, your house. But you don't care whether it is having the brucella, leptospira or some other disease, rabies. So we have to be careful. And tropical zoonosis means within our tropical area. India is one of the subtropics and tropics in between. So this is very important because the ideal temperature 37 degrees to incubate any pathogen. India is the best incubator. Now, what are the diseases? When we have so many diseases, and how to diagnose them? What is the thing? What is important? Because there is a classical method. 100 years back or 50 years back, when you go to a doctor that you have fever, they will give one medicine. For all the diseases, they will give one medicine. That's what they have at the time. But now things have been changed. That is the systematic approach. But now reality is, number one is prevent. Don't go nearby that door. Avoid it. The way we did it in the lockdown system, or lockdown time. Then, availability of the drugs, whether accessibility of them, whether they are randomly used or specifically you are using, whether there is unsafety or not. So there are a lot of issues. What is happening with all these diseases? And the burden, how much it is there. What is happening, all these drugs, whether we should use all of them? You know the reason. You cannot use it. But what is happening? For each disease, there may be a specific pathway. Which drug should be inhibited that particular pathogen? The doctor knows, because we have been studied about that through the years regarding any disease. That is the basic reason we have so much information. What drug should be used for brucellosis? What should be used for TB? You cannot use random antibiotics. They are all going in the drain through us. Now, major tropical diseases, a lot of them there. We have seen all these diseases, but how many people are aware of all those what I am showing there? COVID, yes, we have gone through it, so we are still shaking and shivering. How many people are aware of brucellosis, leptospirosis, glandus, melioidosis, mycobacterium complex? It itself is huge, almost like $1 trillion burden. And anthrax, a lot of foodborne pathogens, all these things are important. And how to diagnose these things? Is there any way of doing it? What is happening in our basic research or else instrumentation development? We have been listening last 2 days, so many things, big data and all those things. All the diagnostics, instrumentation, whatever, 95% is going into all the IPs and patents. They're all the dustbin because nobody uses it. They are in the papers. I got the patent, but nobody wants it. Nobody made it. Why? Because people want it simple, inexpensive, easy to use, always available in the resource-limited areas. Then everybody can use it. It's huge, big, too complicated. No. IVD means in vitro diagnostics. That's what I want to talk about. Most of the IVDs are within the lab or else in the primary health care. I will talk more about rapid kits and a lot of R&D instrumentation sequencers like Dr. Prash is using now, third generation sequencers. Real-time PCR we have been listening last 3 years. Now, what is the IVD for point of care areas in resource limited areas in a village? You cannot bring a lot of big instruments. You need simple, very easy instrument like lateral flow. What is a lateral flow? I think most of you might be seeing this like a pregnancy kit. You might have used a lot of people in the audience. Now, a lot of people also to detect, you can use this for either antigen or antibody test. We will go through those things. This is the lateral flow. Basically, it has a plastic background and you have a nitrocellulose. This has a one side, here the sample pad and here is a wick. It is just like our ink pillar, people use when you have some ink on the table, you just put a absorption pad, just like that. So when you put the sample, blood or urine or anything, it will start absorbing through this and moves through the nitrocellulose, and here this will be pulling it. So here we quote antibodies or antigen to test either antibody or antigen. I will give some example about it. The reason I am showing about this one is a lot of people will be asking. There are very few people who manufacture like us because it is more complex to make and you need special atmosphere. But those people yesterday I have been talking, day before yesterday, a lot of students are asking, sir, what about my future? Can I get a job? What I am saying is, don't ask me for a job. Start making yourself a company. Think about it. You can show jobs for another 10 people. Don't ask me how to everyday fish, but I will show you how to do the fish. So you can feed. Now, the other one is ELISA. This is 400 grams, means you can carry in your pocket, ELISA reader. But in the labs, we are seeing these huge ones, which is around 20 kilos, 30 kilos. But the latest small models are here, and here is a strip. You can read it, and everything is like this 7 inches wide, 4 inches wide, and 7 inches length. Weighs around 400 grams. You can carry on your motorbike also. For Indian purpose, this is the best. These are the two techniques which are very important, carries 90% of the time. Now the other one, which is coming sooner, LAMP. LAMP means isothermal PCR. You don't need, just like PCR, up and down temperature ramping. Only single room temperature also you can do it. 30 minutes, everything will be done. There is a problem is cross-contamination. If you open it, all the applicants will be running around. So we will couple it with the lateral flow with this, so you can read it. Here, the way it happens is, these primer probes, we put one side, Biotech other side is FITC. We will capture it by using the anti-FITC antibodies and gold conjugated antibodies. And here, Biotech and streptodin. So you can see it positive and negative clearly. So this is one very interesting concept which we need it in this country. The third one, the fourth one. Suppose I am a village, the Sakmanjara Modi, and they want to send the sample to Vijnan. And easiest way is just like Watman paper. I think most of the people might be knowing. You can put it on that, and the blood will be absorbed along with the serum. You put it in the serum millware, ship it. It is stable, and we prepare these things. What I am thinking, why I am thinking is how to stabilize that protein, the blood sample. So we stabilize that by using very simple dextron sulfate or else glucose, and we have a combination. See, the way basic researcher thinks, when the data is there, he thinks about how he can do next experiment. I look at his data, how I can make a kit out of it. My brain always thinks only this way. Basic researcher never thinks about the way what the translator thinks. The translation researcher always thinks about a product. He imagines about a product. He won't think about what should be done in the basic research next thing. So this habit, this mindset should be there for translational research. Regarding the COVID, the reason I am going to give is how much time I have. Good. I will try to, because I don't want to be late. Okay, I will spend a little bit more time on this COVID because it hit us 2020, though it came on 19 to Wuhan, but 2020 April, February we started seeing the patients coming into India, popping up here and there, all the big cities. At that time, that's where basic researcher thinks, oh, COVID is coming. Let us go and see how we can sequence it, what is available there, what is going on, can I do this? I started thinking, Dr. Janathan is here, and I pulled him into my office. Hey, listen, this COVID new thing came. Can you go and find out the genes? What is the structure? Within 2 hours he came back. Yes, this is just like other coronaviruses, but I pulled all the sequence. It is already available in the Google. Well, let us think about all the genes. How many are there? 4 important structural genes. All right, put them up. Within 24 hours, he came back, said, hey, this is the gene, this is the structural gene, spike protein, and protein. All right. What I am looking at is, what are the epitopes to raise antibodies? He started, came back, and pulled, these are the epitopes. All right, fine. Put them, assemble them. Then he came up with a 35 kilodalton protein. It is not existing. It is all imaginary. Bioinformatics. And it has covering everything, all the 4 genes. See the way how we are thinking. We want to put this one as a synthetic gene, make it, raise antibodies, make the kit. We want to do it within 2 months. Within 24 hours we are ready. Then we prepared several kits. RT-PCR kit, they already started doing it within the same time. And we already made antigen test, antibody test within 3 months. The shortest time I ever took. This is the COVID, RT-PCR. Per day and night, 24 hours, we have been working at Kurnool. Per day we are doing almost like 4,000 samples RT-PCR, 384. Almost like 18 people are working day in, day out, 3 shifts, helping the whole Andhra. Kurnool, Nellore, Ongole, Vijayawada, Vizag. My job is only go and drive and establish the lab and put it to things. Doing that, all he take care of it, day in, day out. People, everybody is trained in the lab. We stopped everything, only COVID. Cycling. And we put multiplex. There are 3 genes, including the ORF, and 4 of them, and we have all 4 different dyes are there. So in one same RT-PCR, you can see 4 different colors. It means how these 4 genes are behaving. Then we can call whether it is COVID positive or not. Then we had a DBT announced. They invited us, write a grant. We wrote a grant. We got it within 6 months. We also put the whole genome analyzed, bioinformatics basically. Then we came up with 100% highly conserved areas and we made the kit. So basically what we are saying is, can we do it only for product based, not the basic research. So within 4 months, we started working. This is 384 samples in one stroke. We are seeing it. How many wells? This is all wells. How many are positive? How many are negative? You can tell all the blues are positive because there is a 90% of the patients are, all samples are coming to us at that time. Everybody is in full suits. This is a synthetic gene. You can see all the spike protein, E gene and gene, and all of them we took based on the areas are highly immunogenic and we put the linkers and we made it. And this is the protein converted from the nucleic acids to protein, amino acids, and this is a very small 35 kD protein. And we did the lateral flow. Both you can tell exactly it is a positive means you will see positive. So we have so many samples coming in. So we started testing each sample on the spot, both rapid kit compared to the RT-PCR. So we realized that this is working very well, and this costs only 50 rupees. RT-PCR costs 3,000 rupees. So what is the country needs? To screen a village. Is that good? We started shipping for free. Now you can see, these are all screened. You can tell how many positives are there. All are positive here. Yeah, 2, 2, 2, 2. So we were surprised and shocked how perfectly this is working. And this is the antibody test, IgM, IgG. Why we needed that? We are all started getting vaccinated. We want to know whether my vaccine is working or not, whether I am really protected or not. So we did this kit by coating the antigen. Perfectly working. You can tell here this is the IgM because one is IgM, and if you have both, and here some of them are both, and they are like both IgM, IgG, and some are IgG alone. What does it mean? IgM means first IgM shoots up as soon as you immunize, or else when you get vaccinated within 10 days. Then IgM comes down, IgG will start going up. At one stage you may see both of them within 1 month. After 2 months you will see only IgG. This is a well established fact. And now this is important for you. We also got drug license. What is important translational research is it is not only taking the basic research and think about it, design a project, design a product, make the product, validate in-house, take it to the second party and third party, let them validate it, then you go for the drug control regulatory license, especially CDSU. They will give the permission for you to manufacture. Without that, there is no point. So much is involved in this. Okay, now I will talk another disease, brucellosis. A lot of people might not have heard of it. Per year, there is a 28,000 crores of burden on this country. I never believed that. Though I worked on brucellosis in USA for 5 years for the American government in CDC. But in India, I never thought of it. But it is a serious problem. Why? It is highly neglected, dejected, underreported, it is zoonotic. I bet at least 10% of you people might be positive if you are coming from a village, if you have cattle at home, if you are touching your street dog. Yep, this is the dead baby. This is the problem. Abortion. There are 5 strains: abortus, meltensis, suis, oath. And it affects human, cattle, sheep, goat, pig, your dogs. As I said, who are the people who affect more? Veterinarians, dairy workers, sweepers, sewage workers, and people who work who drinks the raw milk. They are at very high risk. If you look at the common, this is not mine, this is coming from the DBT network project. You can imagine there are 14%, 10%, 13% dogs, street dogs, you see 69%. We deal with the street dogs in every village. These are the 4. And what we did was, we are working on a network project. We are diagnostic people. So I look at the diagnosis. So we cloned 10 different genes, put them all together, try to do the diagnostics. Nope, it didn't work, none of them. So we isolated the lipopolysaccharide, which is on the outer side. This is a gram-negative intracellular organism. That's why no drugs works on this, except very few drugs. So if you give antibiotics, it is undulating fever. It comes and goes, comes and goes. You think it is malaria, you think like it is viral fever, but it may be brucellosis. Until unless you test, 20 rupees test, you can rule it out. So we took the lipopolysaccharide, we made the kit. This kit, it has a lot of things, including your 1 rupee glove. We use it for wedding, serving the laddus and all the things. That's okay. You don't want to get contaminated with others. And you have a swab, you have needle, you can buffer, everything is there, instructions also. You can, whole thing is only 20 rupees. It is funded by DBT. We have 10 grants funded by DBT within the last 15 years, and we are so happy. And that's why Professor Padmanabhan, he always, whenever we write the grant, he reads it and then he says, these guys are delivering, do it. And this is the, even milk you can test it. Everybody can test it. These are so easy and simple, and we made several kits, rapid kit, individual kit, 20 packs, ELISA. So my focus is only make the product and give it to the common man and give it to the country, sell it, because farmers are very poor. And also cattle lives outside of your house, dog lives inside of your house. So you kiss your dog, not your cattle. Cattle doesn't have something to say, I'm having the brucellosis. You feel the pain, but nobody knows. So we have to think about these things, and that's why we are making these things and they are available. and they are 88% sensitive RDT, and which we are expecting, and 100% ELISA. Now, leptospirosis. This is another problem. Just like brucella, this is also a zoonotic, animals to human, human. This is in microns, 0.5 micron, 0.6 micron to 20 microns, so length. It means very small, but it is like a big screwdriver kind of thing, and you see it in spirals and it can drill. So you cannot see it with under microscope. You have to see it under the dark field microscope, and it affects. These are the culprits. They carry it. They come out on the street. They pee in the puddles. Especially this is a regional and seasonal. Means in the rainy season, if there is a water puddle, the dog goes and sniffs and touches, it will get infected. Then it will go and pee somewhere else because these leptospira sheds in the urine. The sweepers or the seweragers, they will come, they will clean with the bare hands. They get. What we did was recently, all over the country, we tested all the people, including me and our company and Apollo and ESI. And 20% of the sewerage workers are turned positive because they are complaining fever, undulating fever, joint pains. And what we did was we took 4 different genes and we looked at this is basic research done by somebody else. What I did is, honestly, went into the internet and pulled all the literature, all the data. Then we looked at the 3-dimensional structures and we know which area is important. Then we align them. These are all done by sitting in front of the computer. Designed epitopes based on the immunogenicity. We put all of them together, another 35 kD protein. Boom. Cloned it, synthesized and cloned it, and everything purified 35 kD protein. And you see the specificity, sensitivity. Also, we did the lipopolysaccharide isolated. We added that also, so the sensitivity, specificity increased. The kit looks wonderful, and now everybody is using it. The next one is the glanders. No, most of the people might not have heard of it. It is also called Burkill malai. And in human, the same thing, zoonotic disease. It is called melioidosis. And but in India, this affects more equine population, but up north, especially foothills of the Himalayas and Rajasthan and some areas in Gujarat. And here we see a lot of donkeys like in Kurnool kind of areas. They affect, but it is fatal. Within 5 days, the animal will die. Human beings, if they get it 5 days, that's it. No medicine. So what we did was, this is how you can see there are 2 kinds, cutaneous form. So you can see all the skin, how lessens. And then we have, this is a nasal form. This is very, within 5 days, the animal will secrete all this pus and die. The lungs will collapse. Please let me know how much. Oh, all right. Good. Okay. We did the same way. I don't have to go through the same rationale and same way we did. And Mycobacterium bacteria, this is a very big one. Huge problem. The country has almost like $300 billion burden worldwide. In India at least, definitely minimum 50 billion, but nobody talks about it because a lot of patients are just running around. And so we did the same way. This is bovine TB, and you can see how this animal is just like human TB patients. They also look like that. And now, what we did was we collaborated with the TRPVP Tanvas, and we cloned several genes, not one. We made wild TB, bovine TB, and this is wild TB because we have zoos as well as wild. We have a lot of jungle. And a lot of animals are there. Those forest rangers, they are looking for this kind of thing because those people, they get affected. So we made the kits, and this kit will detect all 5 different varieties of TBs. So this is para TB. We did the same, and we basic research. From there we culture, we took the clones and we made the proteins and we did, and this is a mastitis we can tell, because when we have 20 liters, 30 liters of udders from the animals, they get infected with the bacteria and it will blocks all the teats and milk won't come. That's it. The animal loses the whole teat. Sometimes you will lose 70 lakhs worth of animal which is giving 30 liters per day. So we take the milk, put it in these magnetic beads, and then we shake it and pull the bacteria, and then we check the bacteria if it is there or not by putting the simple blue type on blue color. So and also pH, acidic or basic, because if it is acidic means there is cell growth is going on in the media, so there is a somatic cells are there. So para TB, and this is anthrax. Now it is not as simple as you think. Oh, you made so simple, you are bringing all the kids so easily. No, it is not that easy to organize, to standardize, going through all the things until the drug control and get the license. That is a heavy hell of a problem. Sitting there doing the basic research is one thing, and you think like I don't know what to do with the nest. But these people who are sitting here, like me, they may drop dead in the valley. This is called the death valley, just like Dr. Lohia said. And you can see, these are the people who are looking for the help. So, we have 10 grants, almost like 10 crores of thing, and a lot of people, told singers behind the scene of me, including Dr. Janathan, Monica, Gauss and Muni. We have almost like 30 total, almost like 40 PhD students work behind it, and my collaborators, Professor Kishore and Dr. Prash and Professor Bhatnagar Sohal, and Professor GP is always encourages. Even I know I'm doing something wrong, he says, no, go ahead and do it. That moral support. Thank you very much for listening, and I'm more than happy to take your.
Wonderful presentation, and the organizers were talking about the time. I had no willingness to say that your time is going to be over. I said it is a wonderful presentation, conveying a very good message that research should have translational value. This is the summary. And whatever you intend to do, you should target to a product. And that is what is being conveyed from his presentation. I think it is open for comments and questions. Anybody would like to? Yes.
Yeah, sir, I had a doubt regarding RT-PCR, you have taken all the primer sequences, right? So what all genes you targeted for the COVID-19 PCR?
Okay, in the beginning what I showed is there are 4 genes, ORF, N, E, and S. But later on, and I think we made several different panels of the RT-PCR kits. In the beginning we did that because to screen the national thing. Second one, what we did was, I think he can comment on that. What we did was Jigsaw collaboration. They took the whole genome. They found all the 30 kb whole genome, and then we pulled out some area which is highly conserved with all the variants so far known. And we also, they came up with some kind of a bioinformatics statistics. It will never change because that is such an area. So we are going to patent that, but I think you can talk to him outside. Poster is there, you can go and see it. It is sitting outside.
Sir, excellent presentation, sir. Particularly for our students at Vignan, they are undergoing a course on immunotechnology. And here I wish to get a few clarifications, sir. So you have done this extraction of monoclonal or polyclonal antibodies, sir?
Okay. Whenever we are doing the lateral flow ELISA, people a lot of time ask this. And we always like to have one monoclonal and two polyclonal coming from two different ways. And one easy way of doing the polyclonal is chicken. A lot of people think, why chicken? The interesting thing is you can keep the chicken at home, you can immunize it, it will be running around, it won't go anywhere, it will be eating normal, and it will start laying eggs. Each egg has 8 to 20 milligrams of IgY, that you can use it. Normal egg is 5 rupees, this egg can cost 5,000 rupees. So imagine how easily you can make the money. Second thing, you can also take a goat. We have 20 goats and we always rear them in our farm. We make polyclonal there.
So all through you depend on the goats and not bioreactors?
No, that also we do monoclonal antibodies, we make them, get them, then we use.
Because we develop several kits for several.
Yes, several ways, and sometimes we make outside.
Goat were enough, sir?
Yeah, goats and chicken are good enough, but you can also, we always get monoclonals done by others. Yes.
So another thing, sir.
I think
One minute. With regard to the ELISA that you were mentioning, sir, is it fetter based or single wavelength?
Okay, there is a protein G we use, gold conjugate, which can be used for anywhere as a universal.
Because it's usually very cute and miniature type. We used to have our department at Vignas. So the last one is, you have developed several kits, sir. Have you also developed for gluten virus also, sir?
Yes, I think gluten is there.
Thank you.
Thank you.
you will bring an end to the wonderful presentation.
Thank you.
Thank you, sir, and sorry for posing a lot of constraint on time. We are trying to maintain it. As such, we are already running late by half an hour in spite of not having the third speaker. So Dr. Tangaraj sir is already here, but we will have his session post tea break. And before we break for tea, I have few announcements to make. All the students who have to put up your posters, you're requested to please put it up during the tea break, because the judgment will start after 11 o'clock. So we request all of you to please put up your posters. As you just heard from sir, there are so many stalls that have been put up from all the sponsors. So while you go to the convocation hall, we request you to please look at the stalls that are being put up. And we've been trying to announce this since yesterday. A conference of this magnitude would not have been possible without the support from so many sponsors who have given us financial support. So we would like to read out the names of all these sponsors, and we are highly grateful to them. We have sponsorship from DBT, Government of India, AP Cost, Vijayawada, Andhra Pradesh, Bharat Biotech International Limited, Hyderabad, Unipath Speciality Laboratory Limited, Ahmedabad, Steady Orbit, Hyderabad, Avante Sand, Hyderabad, Punjab National Bank, Guntur, Genomics Carl, Pulivendula, Andhra Pradesh, Hetero Biopharma, Jedchalla, Telangana, Vaster Life Science, Hyderabad, Hetero Drugs, Hyderabad, Zenrise, Bangalore, GK Life Sciences, Guntur, Nagarjuna Biosciences, Seshi Bakers, IHB, SSR Chemicals, Virtue Biotech Private Limited, SD Chemicals, Bros Chemicals Tirupati, and SRL Life Sciences. We thank all the sponsors, and Dr. Tangaraj sir, Director CDFD, also has just arrived. Sir, on behalf of all the organizers, we extend a hearty welcome to you. By the time sir keeps his PPT ready, I think we can have a quick tea break and come back in 10 minutes for Tangarajan sir's session. Before we break for the tea, I request Ratnagiri sir to please felicitate Nirmal Lohia sir for his wonderful presentation. Yes sir. Can we please put our hands together to Professor Nirmal Lohia sir for his wonderful presentation, and also for being an embodiment of positivity. Sir, you are an inspiration for all of us and also for generations to come for the wonderful work that you are doing. Sir, seating is for the comfort of photograph also, sir. You will be captured well. Thank you. Please put your hands together. Thank you, sir. Thank you, sir. I request Lohia sir to please felicitate Ratnagiri sir. Thank you. We thank all the speakers for this session, and I request you all to please take a quick tea break and come back to the venue in the next 10 minutes. Thank you. We are going to continue the technical session which was started in the morning. Our speaker for now is Dr. K. Tangaraj sir, Director CDFT. So we are extremely happy to have you with us. I request Nirmal Lohia sir to please continue the session.
Do we ask all delegates kindly take their seats, please? So that we begin the session. Please welcome Professor Thangaraj. He will be speaking on population genetics and public health. Floor is yours, sir.
Thank you.
Very good morning to all of you. I hope it's audible. It's my pleasure to be here to talk to you about the research work which I have been carrying out for nearly 3 decades. I'm going to give you a kind of summary of the work. How working on population genomics or population study would help us for better understanding of our health and diseases. And before doing that, I would like to thank Professor Ravi Kishore and his colleagues for inviting me to give a talk, mostly our students, and you can realize that how much potential resources we have in terms of population in India. And that gives you idea that how much you can take it forward towards your own research. So when you talk about the population, particularly human, there is no better place than India because of the kind of diversity we have in India. You can see some population, they typically look like Africans. Some population with very light skin color look like Europeans. Some of them with the typical features of Southeast Asians. And some of them are very unique. You will not find that kind of feature anywhere in the world. So it's so much of diversity exists in India. And most importantly, when we talk about population, the Indian populations are stratified in many ways. So one of the stratification is based on the languages. You all know there are 4 major linguistic families. One is Dravidians, Indo-Europeans, Austroasiatic, and Tibeto-Burman. Under every linguistic group, there are several languages. Dravidians, you know that 5 southern states speak Dravidian language like Tamil, Malayalam, Kannada, and Telugu. Similarly, each one of these linguistic groups, there are several languages. This is one stratification. And again, each language, there are several social stratifications. We call so-called caste system. Upper caste, middle caste, lower caste, tribes and primitive tribes. So all of this makes India is one of the very complex nation in terms of the diversity. And in India we have 4,635 anthropologically well-defined populations. You will not see such a huge diversity anywhere in the world. Okay. That includes 532 tribes, 72 primitive tribes, and half of them still practice hunters and gatherers lifestyle. That means they'll just go on the hunt for food in the jungle or forest. They don't do any job including agriculture. So now I will come to the genomic aspects. To understand the population history, understand the genetic basis of diseases, we have to study the genome. Right? In a cell, we have two different kinds of genome. One is the nuclear genome, which we inherit from both the parents. You all know in the somatic cell we have 46 chromosomes. Of that 23 we inherit from the mother in the form of egg, 23 from the father in the form of sperm. Right? So that's a contribution of both the parents. In addition to that, you all know there's a mitochondria in every cell. There are several mitochondria, and each mitochondria has several DNA. It's called as mitochondrial DNA. Okay. While this has only 2 copies, this has hundreds of copies. That's depending upon the energy requirement of the particular organ. The mitochondrial numbers are not fixed. Wherever the energy requirement is more, you will find more mitochondria, and you will find more mitochondrial DNA also. But this mitochondria and mitochondrial DNA, we all inherit only from the mother. There is no father's contribution. This is very important for you to understand. So let me start with one of the study which helped us in understanding the early human migration. This is a part of genetic study, just going to highlight within the limit of half an hour. This is one of the study we studied the Andaman tribes. There are 6 tribal groups in Andaman and Nicobar Islands. 4 of them typically look like Africans. Onge, this is a Onge girl. Great Andamanis, Sentinelese and Java. There are 2 tribes, they typically look like Southeast Asians. One is Nicobaris and the other one is Sentinelese. We have studied the complete mitochondrial DNA, expecting that mitochondrial DNA will look like other mutations are similar to Andaman tribe, similar to Africans. But we found there are several mutations which are not existing anywhere in the world. It's very unique to that population. So based on this mutation, we calculated the age of this particular set of mutations. We put all these mutations together and make a haplogroup. And this haplogroup, that M31 and M32, has not been reported so far anywhere in the world. And we calculated the age of this divergence that happened to be 65,000 years back. So this is the first genetic evidence suggesting that the Andamanis are the first modern human who migrated out of Africa, taking southern coastal route and reached Andaman and Nicobar Islands about 65,000 years back. So this is the first genetic study demonstrating the early human migration. Now I will take you through the nuclear genome. Okay. After completing the studies of mitochondrial DNA and Y chromosome DNA, which we use to trace the paternal lineage, we selected 132 individuals all over India, representing all the 4 major linguistic groups: Dravidians, Indo-European, Austroasiatic and Tibeto-Burman. We also used Andamans. And we used Affymetrix array, which is consisting of 1 million single nucleotide polymorphic markers. We also compared our data with the Human Genome Diversity Panel and HapMap dataset, and we used large number of statistical tools. Using all of these, in fact, we have shown that the Indian population origin actually has come from 2 different sources. One of the source, we call them as ancestral South Indians. That means they are part of the early human migration. This tells that Andamanis have diverged from Africans very long ago. While they were migrating through the southern coastal route, some group stayed in Andaman and Nicobar Islands, whom we call as ancestral South Indian. There was second wave of migration which brought people to northern part of India, whom we call as ancestral North Indians, and they show some kind of genetic affinities with Europeans. There are some other mutation like skin color mutation, lactate persistent gene mutation, all common, which exist both in Europeans and also in the ancestral North Indians. Here the PCA, that's a principal component analysis that shows these are all Indian populations. What we see here is a European HapMap sample, this is African HapMap sample, and this is Chinese HapMap sample. While Europeans, Africans and Chinese, although large number of individuals are there in this cluster, they are in a single cluster, suggesting that genetically they are more homogeneous. Whereas look at Indians, every single population is very unique. Now also there is a kind of affinities between this group, that's why they fall as a gradient of cluster. Okay? Otherwise they would have clustered somewhere here and there. Right? There is a difference, but still we have some kind of affinities. And coming back to this ASI and ANI, then we also predicted that these two groups must have admixed and gave rise to many population groups. That we did not predict at that time when this admixture must have happened. To study that, we used again another set of samples, and before that what we concluded in this study was that all Indians have admixed, as I shown here, and we clearly refuted the Aryan invasion theory because the cluster did not see any group clustering somewhere here and there. We are all in one particular gradient of cluster, suggesting that there's no recent, not very recent, there's a migration suggesting that there was Aryan invasion. We also predicted that there could be a high frequency of recessive mutation in India. To address that, when this admixture took place, as I mentioned, we took another study where we used large number of population from south and also large number of population from the north. And based on the recombination, because every generation, if the chromosome goes, it recombines between the homologous chromosomes. So based on that information, we have used large number of samples, as I mentioned, from both from South India and North India, and we predicted that initially ancestral South Indian gave rise to many population groups, same way ancestral North Indian gave rise to many populations, both ancestral South Indian and ancestral North Indian. You can imagine that some group initially settled in jungle, and after some time group of people must have migrated from there and settled somewhere else, and they must have started agriculture and so on. Then from there one more group migrated to another place. So that's how initially it must have happened. Then during the last 2,000 to 4,000 years, there was a admixture, marriage between these two founding groups. That indicates the genome integration or admixture that is represented here in a different color. So that happened during the last 2,000 to 4,000 years. But after admixture, then every single population started maintaining their endogamy. Endogamy means marrying within the group. We all know consanguinity, marrying within the family. But this is kind of extended consanguinity called as endogamy. So that happened during last 2,000 years. So this is what makes every population unique, because last 2,000 years every population marrying within the population, therefore if there is any naturally occurring mutation, that's going to be restricted only to that population. That makes the difference, because those set of mutations are not in other population, therefore they are very different. Why this happened, we don't know. Probably the caste system which came around 1500 years must have put more pressure on every population to maintain very strictly this particular phenomena of endogamy. Now I will take you through that what is the impact of this endogamy among various Indian populations. To do that, we took again another study where this time we wanted to not restrict it only to India, we wanted to expand our study to other South Asian country also. And if you extend that to other South Asian countries, and now the population number goes up to 5,000 years. Again, very, very high diversity. To do that, there was a background for this, why we wanted to look at other South Asian populations. So in one study where we found a mutation, there's a 25 base pair deletion in myosin binding protein C3 gene, which causes 3 different kind of cardiomyopathies. Cardiomyopathy is a heart muscle disease. The dilated cardiomyopathy, that condition enlarges the heart beyond the normal size. Hypertrophic cardiomyopathy, where the heart muscle becomes very thick. There's the third kind, that's a restrictive cardiomyopathy, where the heart muscle becomes very stiff. Therefore, the heart muscle after some time will have an inability to pump the blood. Therefore, there's a sudden cardiac arrest. If this mutation exists in a homozygous condition, that means, as I mentioned, there are 23 pairs of chromosomes. So if you take chromosome 1, there are 2 chromosomes 1. One we inherit from mother, one from the father. If both of them carrying the mutation, then the individual die at very, very early age, less than 10 years. That we found by looking at the cardiac tissue of the children who died due to sudden cardiac arrest. But if the mutation is in heterozygous condition, it means one copy of the chromosome carries the mutation, other chromosome is normal, then the individual survive up to 40 or 45 years without any problem. After 45 years, then it leads to sudden cardiac arrest. Then we try to look at how the mutation is distributed all over India. We found different state has a different frequency. We found on average about 4.5% of the Indian populations are carrying the 25 base pair deletion in myosin binding protein C3. After looking at that, then we wanted to extend that to other countries also. We looked at the sample from 26 different countries, altogether it's 8,368 samples, and we looked at and found that very surprisingly it is restricted to only in South Asian population, not in other countries. This could be also one of the reasons why this is one mutation, but similarly so many mutations which are restricted to only in India or South Asia. This explains that why Indians are more prone for cardiac or cardiovascular diseases. So coming back to the original story which I was mentioning, that we wanted to look at the impact of endogamy in South Asian population, not only restricting to India, because of this reason. Because this mutation later we found it arose in India about 33,000 years back, and because of the population admixture between ancestral South Indian and ancestral North Indians, it got spread all over India and also to other South Asian countries. So that's the reason we wanted to study the impact of endogamy in South Asian populations. To do that, we selected 2,800 individuals from 275 endogamous groups, and these are where these dots are there, these are the places where the samples have been collected. and the color indicates different linguistic groups, all the 4 linguistic groups, and also isolated languages like Andamanese, Nigalis, and few more. Again, we used 1 million genetic markers. So in this study, surprisingly, we found that the South Asians probably carrying large number of population specific recessive causing disease mutations. So that means there is a lot of opportunity for us or the future generation to analyze large number of such population to understand the genetic basis for large number of diseases which we are not known yet. This slide shows that most of Indian populations are having very high IBD score. IBD means identity by descent. In a simple way, we want to explain, if you take 2 unrelated individuals and get their sequence, maybe 10 kb region, if they are relatives, you will not see any difference between these 2 individuals' DNA. But if they say that they are unrelated, but few generations back they actually come from a common ancestor, then you would expect there is a difference between these 2 sequences. So the number of mutation actually predict that how much is the IBD score. So this is a value of IBD, and there are several lines. All 275 population has been placed here. Each line there are several lines. That's why you don't see from distance that each line is very distinct, because all of them are being placed here, and each population have several individuals. That means 2,800 individuals have been placed here, and there are 2 lines which are in red color. One is Ashkenazi Jewish, other one is Finnish population. So why we included that is because these 2 populations have been well studied, and there are large number of disease and disease causing mutation has been identified in both the populations. This is Ashkenazi Jewish, the list of diseases, and these are the list of genes, mutation which is responsible for this disease, and most of them are autosomal recessive. And a disease condition can classify into 2, autosomal recessive and autosomal dominant. If one of the chromosome carry the mutation and it expresses the disease, then it's a dominant. But it doesn't show any disease phenotype with one mutation, it is recessive. Only when it has 2 copies of the mutation, when it expresses the disease, then it's definitely it's a recessive condition. So when you look at the nature of the mutation, they're all, almost all of them are autosomal recessive mutations. And here these are the list of Finnish population diseases which have been mapped. Again, coming back to explain you how does that matter, whether it's a dominant or recessive condition. This is the pedigree, where you see there's a circle that indicates it's a female, it's a square indicates male, and if you put line it indicates there's a marriage between these 2 individuals. And if you put line down, these 2 are their children, both are daughters, and they have married somebody from outside, right? So it goes like that. But now you look at here, and there's a color, you can imagine that is the mutation, and consider that's a heterozygous mutation. So one chromosome carries the mutation, other one is normal. Therefore, this individual doesn't, although carry the mutation in a heterozygous condition, this individual is absolutely fine, there's no problem. But she married the person who doesn't have the mutation, then she causing that mutation to both of her daughter. Okay, these two. Now both of them married somebody from outside. Again, these two individuals doesn't have that mutation, though it goes into heterozygous condition, goes up to here. Right? Same way on the other side it goes up to here, and you can imagine it goes few more generations. Until these two individuals find its partner with the same mutation, there is no problem with that particular family or community. But if these two individuals who are absolutely fine with the heterozygous mutation, if they marry, statistically 25% of the chance that they contribute to the next generation, therefore there is a disease. To prove our hypothesis, what we have found, we took one disease, well-known autosomal recessive disease called progressive pseudo-rheumatoid dysplasia, and that is caused by mutation in WASP3 gene, and this affects children less than 3 years, and you can see there the joints everywhere is swollen. We took some 30 patients and tried to understand whether all of them are carrying the mutation and all of them having a common ancestor or not. We sequenced and found 6 of them carry the mutation in WSP3. The parents of these children are absolutely fine. Then we tried to understand whether all the 6 have come from a common ancestor. So we sequenced the flanking region of the mutation and tried to see whether all of them are having a same haplotype or not. And we found 5 out of 6 of this patient are having the same sequence or same haplotype, suggesting that today they are unrelated, but several generations back they have come from a common ancestor. This is one more example where there is a consanguineous family, there is a non-consanguineous family. There is a gene called polymerase gamma that is essential for producing polymerase for mitochondrial DNA replication. If there is any error in this gene, that would introduce a multiple mitochondrial DNA deletion. This is the intact about 10 kb DNA fragment in a normal individual, and this is the fragmented mitochondrial DNA of the individual who carry the mutation. And that affects both neurological and also the muscular problem. In this case, what you see, the father and mother who are 45 years and 39 years respectively, they are absolutely fine but carrying the mutation in heterozygous condition. The C is the wild type, T is the mutant. The parents are carrying C and T, that means that's a heterozygous. Same way it is shown here, C and T, and it's very unfortunate that both the parents have contributed the mutant to 2 of their 3 children, and unfortunately all of them have died. And in this case it's heterozygous condition. Now the question is, because we know the mutation, this can be actually screened to the entire family within maybe couple of hundred rupees. Then that can be used for example, if we wanted to marry somebody, either within their own family or somebody from their community, they can actually screen and see whether that individual also carry the mutation. If it is heterozygous mutation, then they can think in their next generation that prenatal diagnosis can be done to look for this particular mutation by taking amniotic fluid and try to make sure that the fetus doesn't carry the mutation in a homozygous condition. This helps the future generation. In fact, this is the way the Ashkenazi Jewish have been practicing this. So they take blood sample of the children who goes to school, sequence and put it in the database, and they have grown and they wanted to marry, for example, boy identify girl, girl identify boy, and they look for a specific mutation whether both of them are carrying or not. So that way, in fact, they eliminated couple of disease causing mutation from the population itself. So in this case again, both the parents are heterozygous, and unfortunately both the children have died because of the mutation. Now I want to tell you about how the population genetic, the prediction as in fact correlating with the disease in some of the population. Particularly, so one of the population here we studied is the color from Tamil Nadu or Madurai. When we collected the blood, we don't know whether this population has any disease or not. But when we went back and we have seen at least 8 families, parents are absolutely fine, they carry a disease called junctional reticular epidermolysis bullosa. That's a skin rashes including oral mucositis and congenital heart disease, and the children die at very early age. It's very pathetic condition. They're all poor. Then we did the exome sequencing and identified 11 base per deletion in gene called LAMB3 against a similar condition. Both the parents are heterozygous for this mutation, and the children are with the mutation, with homozygous mutation, they are dying. So in a country like India where we practice endogamy, so this is one of the major challenge. Most of the individuals carry the mutation heterozygous condition absolutely fine. That happened because one mutation must have arose several generations back in a heterozygous condition, because they are marrying within the group and the frequency of the mutation got well spread in the population. But after it reaches to certain frequency, there's a possibility that 2 individuals with the same mutation in heterozygous condition marrying and giving this kind of diseases. We are also taking some more population based on our study, the population study. So these are some of the population including Kallar, Yadav from Pondicherry, Kalinga, Reddy from Anuparthi, Handikudu is one of the region in Karnataka. They have very unique disease. Udanam, you all must be knowing that they have kidney disease. Vaishya, they have pseudopolyinesterase deficiency. We are sequencing the whole genome of these 3 populations and the exome of some other population to understand the real genetic cause. This is Handikudu, what you see, they are very short statured with bone abnormality, with severe pain. And this is a Udanam kidney disease. Most of the population undergo dialysis. With this background, we wanted to address this major issue by looking at the genetic mutations, and this is a very new program launched yesterday by Secretary Department of Biotech. One of the reasons why I could not come on 31st, and we are collaborating with 15 different centers all over India, and they will initially screen for the known mutation. If there's no mutation, then we take those samples with, we'll go for either exome sequencing or whole genome sequencing, identify the mutation, predict whether that mutation is really cause for the disease. Then we use different animal model to understand whether this mutation is really causing the disease phenotype in these models. Then we try to also treat some of the diseases using CRISPR-Cas technology and take back that information to the patient and the family and also the population. So this will help the common people with known or unknown rare genetic diseases. So one aspect which we wanted to take it is to make awareness of this program, because most of the populations are in the rural area, and they are the one who practice the endogamy, and they are the one who carry large number of such diseases. And maybe you can also spread this word, whosoever who you like or whosoever having such kind of diseases. So with that, I would like to thank all those who have participated in this entire studies, including acknowledging and most of my students and colleagues from outside India, inside India, and most of the clinical collaborators, and also the funding agency including CSIR, UK India Education Research Initiative, DBT, DST and Medical Research Council at London. Thank you very much.
Thank you, Professor Anrajan. Wonderful presentation. Thank you, all of you. I think the presentation is open for comments and questions. Yes, you identify yourself and please ask me questions.
Hello sir, it was a scintillating talk, and I'm a PhD scholar. Basically I'm working in the area of glamma and drug discovery. But I have few questions that you mentioned with reference to hypercardiac myopathies that you identified that gene. So is it correlated with ischemic stroke symptoms also?
No, this is a very unique phenotype. Unless otherwise you do 2D echo, you may not even find with ECG. Okay, this particular phenotype, because either the heart ventricle particularly enlarges and the heart muscle become very thick, right? Sometimes may be associated with other diseases, otherwise it's very unique phenotype.
Thank you, sir. And the next question is, with the present scenario that we have, like because most of the diseases are at the root and it is related to the genetic mutations, sir. So will there be any possibilities like to therapeutically target the genes instead of the proteins to restore them back to their wild type?
Yeah, there are few attempts even for cardiomyopathies, but it's not taking up to the level that people think because of target effect, and also it requires a lot of regulatory things.
Thank you,
But
sir.
it's possible.
Thank you, sir. Thank you, sir.
No session can go forward without his asking questions.
Thank you, sir. I am Professor Prabhanidhi at Vignan University, sir. So one or two doubts, sir.
Sure.
So, sir, in Hispanic population there is retinitis pigmentosa. In our African population there is sickle cell anemia. So like this in Indian population we have this what you were mentioning MYBPC3. Is it uniquely recessive in India?
So it arose around 33,000 years back and got well spread in India and South Asian countries. Original people from other countries don't find, unless otherwise they have recently migrated from India or South Asia.
The graph shows it's exclusively for Indians.
South Asia.
South Asia.
Yeah.
So the other important thing is for 2022 Nobel Prize scientific, any of our Indian what is it called genes or nucleotides being shared, gene flow is there from Neanderthal or Denisovans.
Yeah, we have in one of our study, which I have not shown here, with major collaboration, 300 whole genome has been sequenced, some from India and throughout the world, and we found that population who moved out of Africa, they all carry up to 3% of Neanderthal genome, and particularly population towards East Asia, so they carry up to 0.5% of Denisovan genome.
Tibetans are sharing more.
Not Tibetan. So the population living throughout the world except Africa, because this happened, the admixture between the human and the Neanderthal happened after the people have migrated out of Africa. And so that we predicted that up to 5% of the population who are living outside Africa carry the Neanderthal gene.
So is there any laboratory in India to provide the genome analysis of individuals?
So there are many private labs, even some of the government institute like CCMB, but we mostly take for the medical conditions, but not for anybody want to sequence and ready to pay money for the expenses. Now for the whole genome it costs around 50 to 60,000, and the whole exome costs around 16,000. Yeah. I remember when we sequenced the first time, it cost about 5 lakhs one individual.
Thanks a lot.
Last question.
Sir, yesterday we had a wonderful panel discussion taking the cognizance of Svante Pabo's Nobel Prize in Chemistry and in Medicine. The panelists, including Yaneshwar, we discussed something on that 50 kb region where there could probably be regions that could be attributed to pathogenicity. So given the sublime increase in the number of genome sequences that are happening over the years, what could be the next frontier in terms of focusing those pathogenic rich lineages within this 50 kb fragment and taking this to the Indian Genome Project as well?
We are running sort of
That's the point which we thought of
Yeah.
having you.
Yeah, you said Yaneshwar told, because in that study where Yaneshwar and myself, we looked at the 50 kb region among Indian population. The original conclusion of Pabo was that he took sample from the hospitals in UK, mostly Bangladeshis, and which he is referring as a South Asian, and also the local European. And we found that more number of South Asians have been admitted in the hospital compared to the local European. That's why he says that because they have inherited this 50 kb region from Neanderthals, that makes them susceptible for infectious disease. But we did not find any such difference. In fact, India was doing much better during COVID time. So we have shown the paper that nothing of that kind. So later we also found recently another paper, Santhi and his group, another region, chromosome number 2 I think, just 2, which he found except Africa, everywhere distributed the same frequency. He said that this is the region which gives resistance against infection.
I think give a big hand to Professor Sangayan for a wonderful presentation. Thank you so much, sir.
Thank you, sir. I request Lohia sir to please felicitate Thangarajan sir for his valuable time and precious talk. I request Lohia sir to please continue chairing the session till Prakash sir joins us. We now have a talk by Dr. Spandan, Director, Molecular Biology, Unipath Specialty Laboratory Limited, Ahmedabad. He is going to talk on Unigenome, a way forward in genomics and research. Over to you, Dr. Spandan.
Little behind the schedule, but interesting talks. It becomes at times difficult to say no to either the speaker or the audience asking questions.
Good morning everyone. So I would like to thank Professor Ravi Kishorji, Dr. Prash and Dr. Anilji for inviting us to this wonderful conference. I have been part of this Syndics 2016, I think, before this conference, and it has reached a level. It is the status of this conference is truly on the second or third level. So I am extremely obliged to give a talk and to give information about my company here in this conference at this stage. My name is Dr. Swandar, and I am a senior scientist at Unigenome. Unigenome is a life sciences division of a lab called Unipath. So I will give you a brief about Unipath, then Unigenome, and then all the NGS services we are catering, both in research as well as the clinical segment. So this is the headquarter of Unipath Labs, which is situated in Ahmedabad, Gujarat. Unipath has around 35 labs, more than 35 labs in around 19 states of India, as well as out of India also we are having in neighboring countries. Our labs are there. Even in Hyderabad we have one of the biggest lab of Unipath. Unipath is 12 years old company, just a 12 years old company, but you can see we are there in all these specialties, starting from molecular pathology, cytopathology, biochemistry, immunology, serology, everything. Unipath offers 1500 clinical laboratory tests, and it does this 50 lakhs tests per year, and this is not including COVID, it is excluding COVID. Unipath offers comprehensive range of clinical laboratory tests for prognosis, early detection, diagnosis, with the state-of-art equipment that has been designed to provide quality reports. So Unipath, if you say the other name of Unipath, that is quality. We believe in quality, and we have, you can understand, you can have the idea of like quality which we believe in, because we have around highest registered test in the NABL. So NABL is very important when you talk about the quality in terms of laboratory. You won't believe in 2019, the last accreditation, we have registered 500 tests only from a single branch from our head office in the NABL. So these are all the high-end equipments which we have with all the departments. This is biochemistry department. This is hematology department. So all the high-end equipments and the experts are there in every department. Most of the doctors are from CMC Vellore, and they are having rich experience. We perform around. We have the capacity of specifically in case of molecular biology department, our capacity has reached about 10,000 tests per day in terms of COVID, and we offers around more than 200 tests in different clinical diseases. This includes infectious diseases, genetics, molecular, hematology, oncology, and now we have set up our different division called Unigenome. So Unigenome is basically a part of Unipath. Unipath has all these departments. The new department is Unigenome, which caters to NGS research and the clinical segment. In the research segment, we have all the services which is available in India, and in the clinical segment, we have all the panels and the disease identification services available. Platforms we have are the latest one is NovaSeq 6000. Then the Genexus is also we have, which delivers the report within 28 hours from sample to report. This is fully automated system. Then the iron torrent platforms are also available here. Apart from this, we do have our own servers where we do the data analysis of exome and genome sequencing with terabytes of RAM and petabytes of storage. So now I will give information about all the clinical tests which Unipath offers. So we offers in the clinical segment the exome sequencing, genome sequencing, targeted panels for solid tumors, myeloid malignancy tumors, liquid biopsy panels, NIPT, comprehensive genome profiling, as well as the customized panels. So this caters around 90% of all the available tests which are there in the market in the clinical segment. Before we move into the next slide, we have to have some information about like what is sequencing coverage and depth coverage, because in next slides you will be hearing that at this much X coverage you have to sequence something or that is there. So that's why I have put some definition of this. Both terminologies are very important. The sequencing coverage means how much of your targeted region is covered. For example, if your genome size is of 50 MB and the data generated is around 45 MB of your interest, so your coverage is 90%. So this is nothing but the breadth of coverage, right? And depth coverage is the number of times a single nucleotide is read by the sequencer. So for example, for 100x coverage, if your genome size is 41 MB, which is the exome size of human, if you want to cover it at 100x, you have to have 41 MB of data mappable reads, which will cover your exome at 100x. So this is nothing but the depth coverage. So these two phenomena are very important for understanding of next few slides. Now there are many applications are there for which the NGS can be used, especially in case of the clinical genetic testing. Right now the latest one is the whole genome sequencing and exome sequencing. These are basically performed to identify point mutations, small indels, copy number variations and structural variations as well. And then transcriptomics and RNA-seq is performed for differential gene expression, gene fusion, alternative splicing and RNA editing. This is upcoming in case of the diagnostic setting, but this is already there, and we also offer, and many labs are offering this, the exome sequencing and genome sequencing. Epigenetic, which includes bisulfite, MEDIP and chip sequencing, which is basically methylation studies. There are example of each diseases which can be done, which are done by this in today's scenario as well. And there are few important diseases which are under research category by these applications, which will be coming up in diagnostic setting within few years of time. Now we come to exome sequencing. Exome sequencing can be of different sizes with reference to the data which is required to cover that. So normal exome sequencing, which we call it as clinical exome sequencing, this has around 4,400 genes, more than 4,000 genes, which will be covering all the clinical genes which are relevant for most of the cancers. So the capture size is 12 MB and this requires 200x coverage and 3 GB of data to cover this entire region. The whole exome sequencing, it has the capture size of around 41 MB with 22,000 genes, and here there are two options, 100x and 200x coverage is there. So there are two significant differences between these two coverage, because the price will also different. So at 200x coverage, if you want to do any structural variation CNV analysis, then you have to take data at 200x. So these two options are there for with us. And then extended exome panel where 20,000 genes. So here in this case you are only targeting the exonic region, but in this panel we are targeting intron exon junctions, not only exonic region plus intron exon junctions and plus UTR regions as well. So there in few rare disorders there must be mutations which are there at the splice sites or the UTR regions. Those all are covered in this one. This is the extended exome panel. It is the largest panel of 65 MB. The recent updated one is around 71 MB of panel. Here at 100x also you will read around 10 GB of data. On the analysis front, we offer our own pipelines as well as the third party softwares also, like Varsome, Sophia, Golden Helix, etc. And the platform we use is NovaSeq 6000 and read length we use is Parent 150. So basically how we perform exome sequencing, or anyone can perform exome sequencing, is by preparing first the genome library and then capturing it by specific probes with the hybridization reaction, which will be based on then biotin streptavidin chemistry will be captured again and amplified for the sequencing to generate the data. Once the data is generated, the analysis can be divided into three parts: primary, secondary and tertiary analysis. So all the after the data generation, the QC of the data, filtration to remove adapters, up to that part it will come under the primary analysis, and the secondary analysis will be mapping of this data onto the reference genome and calling out the variant file, that is called VCF files, variant caller. So this up to this variant calling, it is the secondary analysis, and the tertiary analysis is after that, which includes annotation, then classification of variants according to, if in case of germline mutation as per ACMG guidelines, in case of somatic the other guidelines is also there. So based on that we have to follow this, and finally phenotype genotype correlation will be done, and this is the third tertiary analysis. After that final reporting is done. So now we have started offering, this is the latest one, the genome sequencing, clinical whole genome sequencing. This again we have two options here to be, it can be done at 30x and 40x coverage. People usually in India are performing at 30x coverage with 90 GB of data. One more option is that with 120 GB of data, and this is done for if you are not getting any answer from the clinical exome sequencing or whole exome sequencing, you have to perform the whole genome sequencing. This includes the CNVs, SNPs, indels, structural evaluation, everything is covered when you are performing the whole genome sequencing. Now these are all the panels which are offered by Unipath in the oncology segment. So here you can see the myeloid. There are 3 assays which we are doing it in 7 to 10 days, and this is the practical TET. This is the shortest TET which is offered by any of the service provider in India, because we are performing this on Genexus, which gives report within 24 hours. So there are 3 tests: myeloid, specifically myeloid malignancies. Either it can be only DNA, only RNA, or both. And one of the precision assay panel is there, which includes mutation, CNVs and RNA fusion. This is a 52 gene panel. This also we delivers within 7 to 10 days of time with analysis and final clinical reporting. After this we have many other panels which include like hotspot panel, 50 gene mutation, 50 gene panel, then 161 gene panel, and also 546 gene panel, which is the CGP kind of thing, comprehensive human genome profiling, which is similar to whole genome sequencing but in the clinical context. So in clinical context, if someone wants to know anything, so they have to go for this comprehensive profiling, which includes not only mutations, fusions, CNVs, TMB, MSI and HRR also. So this is clinically very important, and this is the final answer to get for any of the diseases. Apart from this BRCA, germline, somatic, these are also there. And liquid biopsy also we can perform within 7 days of time, or even in less than that time if we are performing on the Genexus, this using this 52 gene panel. And we are soon going to launch the HRD assay. So this is the glimpse of our the 2 important panel which is having the least TAT of 7 to 10 days. This is the myeloid panel. It is the most updated panel available in the Indian market, I would say. We are one of the lab who are involved in the early access program by this. This is from the Thermo Fisher, and this includes the important GC reach region and FLT3 also. It is covered in this panel. And another panel is the Oncomine precision assay. This also includes important fusions which are NTRK 1, 2, 3 and 4. These fusions are not covered in any other panels which are available in the Indian market.
Could you kindly sum up another few minutes?
Sir, it will take minimum 5 minutes.
What I just suggested.
I have already asked. So Unipath also offers the NIPT services under the name of Unicat. So Unicat is the Unipath non-invasive chromosomal aneuploidy detection. This will give not only 13, 18, 21 but all the chromosome details And along with that, there is one more option, that is NIPT Advanced. So we also do this. So in Advanced, we also detect the micro deletions. So basically, NIPT is done by low-pass human genome sequencing, and it requires track tubes to transport the samples. This is one of the assay which is latest developed. This is called IRMA by NGS. This assay is developed by me. This is nothing but the imatinib resistance mutations analysis on or BCR-ABL1 kinase domain analysis. So what happens is, when the patient is of CML patient, when they are there, so in case of CML patient, primary drug given is the imatinib, and if patient is developing any resistance to that, then he or she has to move on to secondary drugs, either dasatinib or ponatinib or anything else. But to move on to the another therapy, he has to go, or he or she has to go through the this mutation analysis, which is traditionally done on Sanger sequencing, which will give you a sensitivity on the lowest side at up to 20%. So ideally it is suggested to do by NGS, but in NGS there is no kit is available or no any commercial assays available to do this. But by NGS, if you go, it will go down to 1% sensitivity, and it is possible to have complex mutation or more than one mutation together, which will be very important for the patient to know at the first time diagnosis. What happens usually is, if we go by the Sanger at the first stage, if it is less than 20%, it won't be detected. Patient will be suffering for the same disease. It will be in the advanced stages of the cancer if it is not detected at this early stage. So because of this assay is required in higher, the requirement of this assay is very high. In India, only MedGenome is performing, I think, this assay, and but there is certain guidelines which has to be followed when you are performing this assay. That is the cDNA preparation. After that, you have to amplify your specific amplicon. Either it is for in case of major 210 or 190 or 230, you have to perform that specific amplification, which is missed by most of the, I think, service provider or the assay who are performing. So as per the European guidelines, you have to do this by kinase domain specific primers, and then only you can perform the amplification, and then you have to do the sequencing. So we have done this using ion torrent, and so this is the coverage. It covers entire kinase domain region from the codons 162 to 500, and we have performed this. It covers all the kinase domain mutations, and in the initial studies we have found that it is 100% concordance, and even it is giving more mutations because it is more sensitive than the Sanger. So till now, initially we have sequenced 25 samples with this assay, but till now we have done around 100 samples, and all of them are giving more insights comparing to Sanger. It is but obvious because Sanger can do up 20%, this is going up to 1%. In terms of research offerings, we are there in all the applications, either it is in RNA sequencing, genome sequencing, small RNA sequencing, or single cell sequencing. This all are the services we are offering, and as well as the analysis also we are offering. So if you have the data and you just want to do analysis, you can give us, we will do the analysis for you, that is also possible. This all are the applications. I have already given this talk in the pre-conference thing. So this is whole genome sequencing of anything, bacteria, fungus, virus, any unculturable or pathogenic organism, even mitochondrial genome. And amplification based sequencing covers 16S, 18S, all of this. Epigenetic studies, GBS and DDRAD, this both are used for the plant breeding. And the clinical research, which we have already talked about. So genome sequencing, we offer de novo and reference based both. In case of plant, we are using hybrid approach, which is along with the Illumina, we are using the PacBio or nanopore also, because plant genomes are more complex. We have already the team who have worked on the rubber genome, jute genome, pigeon pea and castor plant genome projects, but in bits and pieces. Not the entire genome sequencing was done by us. In metagenomics, we provide all the amplification, amplicon based as well as shotgun metagenome sequencing, and In mitochondrial sequencing, we have, I think we have one of the client from this university also who is giving us sample for the mitochondrial genome sequencing. Usually it can be done through two ways, either isolating the pure mitochondrial DNA or doing the total DNA sequencing and extracting mitochondrial genome, and third way is to perform the amplification of mitochondria, which is possible only if you know the reference genome. For example, human. If it is unknown, like a plant, you have to do, or any insect, you have to do this isolation of pure mitochondria and do the sequencing. So library, this is a yes, yes. So this is GBS and DDRAD. So basically done for the by the plant breeding scientists who are working on the plant breeding. So they perform this GBS and DDRAD in practical. In today's scenario in entire India, only one or two service providers are there who are actually performing this DDRAD. Otherwise, most of them are doing the outsourced business. So we are having this assay developed at our lab, both of them, GBS and DDRAD. In case of RNA transcriptome sequencing, so this is RNA sequencing can be a whole RNA sequencing or only mRNA sequencing. If you are interested in studying long non-coding and other RNAs, tRNAs, microRNAs together, then you have to do the complete RNA sequencing. If you are interested only in transcriptome, then you can do the mRNA sequencing. So these are all different types of RNAs, and this is the protocol we follow. Only step difference is the ribodepletion or mRNA enrichment based on the requirement of long non-coding of this RNA. These are all our partners, and if you have any questions, this is my team work with us. Thank you.
So sorry for because of the pressure of the limited time. It's been a wonderful presentation, and I think we can have one comment or one comment. I think.
Sir, how is that exome sequencing predicts the late onset of diseases?
Which transcriptome?
Exome sequencing. How does it predict late onset of diseases?
Late onset of disease. Okay. So exome sequencing basically predicts, basically it gives you the glimpse of the mutations or variations which are there. So based on if you are targeting any disease, you just have to identify the genes which are involved or pathways which are involved in that. Then you can extract out those variants which are specifically there in that particular genes, and this is how you compare with phenotype, match with phenotype and phenotype ratio.
Another important
question. No more questions. No more questions.
Thank you.
You should honor
Sir,
the chairperson.
Sir, we can talk outside.
We can talk later on.
Yes, sir.
Because if I keep on requesting to sum up, and if it is not listened, then the chairperson has no meaning to be there. And there is a lot of pressure from organizers to always giving me, conveying, please, we are running behind this. Sorry.
No issues, sir. No
We can have more discussion during lunch time.
Definitely.
And we appreciate your presentation. Thank you so much. Give a big hand.
Yeah, he's here. Like 12-15 minutes. Dr. Ravi.
Dr. Ravi. Okay. The next presentation is Dr. Ravi. Please.
Sir, he needs something.
I think we have already invited. Let him do and don't make a mess of it. And I should not be there in the picture. We should be clear as to what we want. He has how much time?
15 minutes.
Only 15 minutes.
Okay, please honor.
I will try my best.
అట్లా కాదు నీ దగ్గర 64 కెమెరాలో సురాజ్ గారు ఎక్కడ ఆయన కెమెరాలో అదే కార్డు అయిపోవచ్చింది. ఇంకా 45 నిమిషాలు ఉంది. అట్లా కొంచెం అది ఫుల్గా ఉందా? సరే సరే ఒకసారి వస్తుంది చెప్తానంట.
First of all, thanks to the organizers to giving me this opportunity. So, by the way, I am Ravi Kumar, representing MJ in this conference. So, I am taking care of the technical support and product management for India on behalf of MJ. So, today I am going to give you a brief introduction about a application called STLF, Single Tube Long Fragment Reading, which is a novel and cost-effective approach, especially for the de novo genome assembly. So, this is the outline of my presentation. Because of the time limit of 15 minutes, I need to skip some of the slides. Please accept my apologies. Yes. So before going into the presentation, I would like to give you a brief introduction about the product portfolio available from MGA, especially for the molecular diagnostics and precision medicine, apart from the academic research. So here you can see that the genetic sequence available from MGI. So we have three series of especially genetic sequences. E series, which is not available in India at the moment, it will be available from January 2023 onwards. So in G series, we have two platforms, G50 and G400. So which can generate the data output of 150 GB, which is from G50, and G400 it is having two slots, it can generate up to 1.4 TB data. So especially for the service providers or for the projects of whole genome or whole exome sequencing, then better to use G400. In T series we have two platforms, T7 and T10, which are ideally designed for the whole genome sequencing, especially for population genomics. Because T7 it can generate 6 TB data in 24 hours. T10 it is completely for population genomics only, because it can generate the data output of 72,000 GB in 3.5 days. And apart from the genetic sequences, we have the automation platforms also, especially for the automation of the sample processing, starting from the sample preparation, extraction of nucleic acids, and library construction as well. So because of the time limit, I will skip these slides. So here you can see that on the x-axis the data output in GB, on the y-axis the instrument price. So the higher the data output, the higher the instrument price. Okay. So especially we have one more platform, G series G99, which is ideal for the small panels and also whole exome sequencing, clinical exome sequencing for limited number of samples. So this will be available from January 2023 onwards in India. So apart from the genetic sequences automation platforms, we have the consumables starting from the sample preparation to the final reporting as well. So we will call it as total solution, because those people who purchase the MGA platform, they don't need to go for any third party one. So we do provide everything starting from the sample preparation to final report also. Especially for the oncology and the whole exome sequencing, we partnered with many third party companies for the reporting, especially in Genetics and Congenica. So in the bioinformatics product portfolio, the first instrument platform released into the market is Megabot, which is having a 36 CPU core, and RAM is 192, and the data output is, data storage is 30 TB. So apart from the analysis pipelines, it is having hardware called FPGA, field programmable gate array, which can accelerate the data analysis of whole genome and whole exome by 20 times. For example, 100 GB of the human whole genome data can be analyzed by Megabot within 2 hours only. So especially for the T series, we have a Gtron Pro, which is having a higher CPU cores, 250 CPU, and the RAM is 1 TB, and the data storage will be 1 PU, 1000 TB in total. So it is also having the FPGA, which can accelerate the data analysis of whole genome and whole exome. So the higher, the ideal bioinformatics platform for the different platforms is, for example, G series and D series, Megabot is more than enough, because Megabot, it can analyze the 1.4 TB data coming from the G400 within 2 days only. So whereas for the G400, for the higher sample volume, so better to go for the G-Bolt Pro, which can analyze 1.4 TB data in 1 day. So for the T series, T7 and T10, which can generate the 6 TB and 72,000 TB, Gtron Pro will be ideal, because especially it can analyze the data within 3 days, and it is not only the analysis software, it is the data management system also. So coming to the DNBSEC, DNBSEC stands for DNA nanowire sequencing, which is developed by a US company called Complete Genomics. So the advantages of DNBSEC core technology is the data accuracy, especially for the insertions and deletions. It is possible to get 90 to 99.4% of the precision and sensitivity by using the DNBSEC. If you see the competitor, like especially application note from Illumina, their precision and sensitivity for the index is less than 94%. And second advantage is the duplicate ratio, which is reduced, especially if you use the PCR free kit, the duplicate ratio will be less than 1% only. So index hopping is almost zero in our case, whereas the competitors like Illumina, index hopping, that means the data of sample 1 will be added to sample 2 by mistake or sample 3 by mistake. So for the competitors, the index hopping is around 2 to 3%, but in our case we use 10 less indexes, so that's why index hopping is almost zero in our case. I will skip this one. So till date we have around more than 2000 publications because we started manufacturing the platforms from 2016 onwards. So more than 42 publications are published in the journals which are having the impact factor more than 20%. So we have the publications in almost all applications. So I will skip this slide. So coming to the de novo genome assembly, there are two kinds of, once we get the data, especially from the short read sequencers, we have two kinds of mapping, reference mapping or de novo mapping. In reference mapping, the reads will be aligned to an existing reference genome. Okay? So whereas in de novo assembly, there will not be any existing reference genome. So the overlapping reads will be assembled into the contigs and overlapping contigs will be assembled into the scaffold. The scaffold size will be Kb to MB in size. Okay? If there are any gaps in the scaffolds, they will be filled by the short read sequencing. Again, the overlapping scaffolds will be assembled into the chromosomes. So the advantage of de novo assembly, it can produce precise reference genome, reference sequence, especially for the polyploid genome like plants. Okay, especially short read sequencing, it will not complete the genome sequencing for the polyploid genomes, especially for the plants. And de novo assembly, it will give the valuable information for the novel organisms and also it can complete the genomes of the known organisms and it can resolve the repetitive regions also. So it can identify the structural variants and complex rearrangements as well. So the differences between the short read sequencing platforms and long read sequencing platforms is, especially the plant genome assemblies which are generated from the short read sequencing, they do not have the uniform read coverages. So indicating that there are some issues in the assemblies. Whereas the long read sequencers, especially coming from the PacBio or Nanopore, they can do the de novo assembly of the unknown genomes and they can resolve the repetitive regions also, especially for the, it will be helpful for the polyploid genomes like plants. However, the long read sequencing using the third generation platforms like PacBio and Nanopore, they are very expensive, especially Promethean from Nanopore and PacBio, they are very expensive. Instruments are also expensive and also sequencing reagents are very expensive. So apart from that, they require short read sequencing also, because in long read sequencing also, definitely there will be some gaps. So the gaps should be filled again with the short read sequencing. So that's why MGI, they developed an application called STLFR, single tube long fragment reading, which is a technology by adding the barcode to the long DNA molecules of the sample, then we can use the short read sequencing to get the sequencing. Then by using the barcode sequencing, we can cluster the reads coming from the long read DNA. So by using the Nanopore or PacBio, it is possible to sequence greater than 100 kb length DNA molecules, whereas it is expensive, as I mentioned earlier. And the long read sequencing platforms, they have the higher error profiles, especially compared with the short read sequencing platforms. And they do require the error correction by short read sequence, which is called as a polishing. So that's why our CSO, Chief Scientific Officer, Dr. Red, he has developed this STLFR technology. I will mention the coming slides. So this STLFR, it is combining the advantages of long read sequencing or short read sequencing. So for example, long read sequencing, it can read the long DNA molecules. but it is having low data accuracy and higher cost. So short read sequencing, it is having the higher data accuracy and low cost, but it cannot read the long DNA molecules. So STLFR technology, which is developed by our company, it can read the long DNA molecules by using the short read sequencing platform, and it is having higher data accuracy and lower cost compared to the PacBio and nanopore. So this is the workflow. Especially here, please note that we require 1.9 nanograms of the high molecular weight DNA, which should be intact. Then only this application will work very well. So barcoding means, especially in the short read sequencing, we add the barcode to the fragmented DNA of the sample. That means the same barcode will be added to all the fragments coming from the sample. Whereas in STLFR, we add the barcode to each long DNA molecule at regular intervals. That means, for example, here you can see that. So there is a DNA that it is having, for example, here 6 long DNA molecules coming from that sample. Okay. So each long DNA molecule will have a different barcode at regular intervals. For example, for long DNA 1, so barcode 253 is added, which is shown in black color. Second one is having different barcode. Third one is having different barcode. Like that, each long DNA molecule coming from the same sample will have different barcode. So by using this barcode, we can cluster the data coming from this long DNA molecules. Okay. So the workflow is this is the workflow. There will be 4 major steps. The first step will be, so we add the 2 known transposon sequences. So for example, this is the transposon. So there will be a transposase enzyme, and there is a transposon which is having 2 known transposon sequences. One will be single stranded, which is used as a hybridization sequence. The second one will be double stranded, which can be identified with this transposase enzyme to maintain the DNA long fragment structure. So this will be added. Transposon will be added to the 1.5 nanograms of the high molecular weight intact DNA. So then the transposon will transfer this DNA structures into the long DNA molecule at regular intervals. Then by using then this transposon inserted DNA will be added to a clonal barcoded bits. Each bit will have 400,000 copies of the same barcode at on the surface of each bit, there will be one same barcode which is having more than 400,000 copies. So for example, if we use 1.9 nanograms of the DNA, it will have more than 10 million long DNA molecules. So that's why we are using more than 30 to 50 million unique barcode bit. Each bit will have the 400 copies of same barcode also. So once the transposon inserted DNA is added to the in solution bits, so the transposon will be captured by the bit using the hybridization sequence. Yeah, here you can see that on the surface of the bit there will be a capture adapter, and there is a barcode, and there is a splint oligo, which is a complementary sequence to the hybridization sequence added to the DNA at regular intervals through the transposon enzyme. So by using this splint oligo, the long DNA will be captured by the bit on the surface of it. Okay. So then the barcode will be transferred to the long DNA molecule at a regular intervals.
Dr. Ravi, you have another 2 minutes.
Okay. Yeah. Okay. I will skip this one. Yeah. So then after the sequencing using the parent 100 read length, so we use the barcode sequence to cluster the data coming from the long DNA molecule. For example, I will mention here. So then we tested how many long DNA molecules are captured by each bit. So for example, here more than 85% of the long DNA molecules have been captured by one bit only. That means ideally one long DNA should have the one barcode only at regular intervals. So there are some long DNA molecules which are having 2 barcodes. That's why we require very intact high molecular weight DNA. Then only we can increase the percentage of the long DNA molecule having one barcode only. So yeah, so here coming to the variant calling accuracy, using this long DNA molecule, we were able to get the precision and sensitivity of 99.9% for the SNPs, which is similar to the short read sequencing. For Indians also more than 96% of the precision and sensitivity using the STLFR data. So coming to the performance, we tested the de novo genome assembly of the human using this STLFR data. We were able to get a scaffold N50 of 29 MB, which is similar to the PacBio nanopore. Okay. So when we assemble this STLFR onto the H18 chromosomes, it is having high accordance. So later we tested the hybrid assembly, especially those people who are using the backbone nanopore, they use the hybrid assembly. So we added 30 GB data coming from the same sample from nanopore. Then we tested the scaffold N50. It is 50 MB scaffold N50, which is better than the backbone nanopore. So please note that why do we did this hybrid assembly? We can increase the scaffold N50 and the cost is very low compared with the backbone nanopore. So that here you can see that the coverage coming, the genome coverage coming from the hybrid assembly is more than 95%. So which is similar to the backbone sequencing, whereas it is really better than the Promethazine sequencing coming from the nanopore. So Promethazine the coverage is only 86%, whereas hybrid assembly coming from STLFR is 95%. So backbone coverage is 96%. Whereas if you see the cost, it is very low cost compared with PacBio and nanopore. So that's why, yes, okay, done. Yeah, so this is successfully used to sequence the TQ DOS, which is having a genome size of 276 MB, and we were able to get a scaffold N50 of 5.32%, 32 MB. So we were able to successfully use this STLFR assembly to get the genome assembly of more than 30 marine species, and we were able to get more than 90% of the genome coverage using this STLFR data. Yeah. So coming to the summary, especially long DNA molecule, it is long read sequencing will be really useful, especially from the backbone nanopore. But it may require the short read sequencing also to fill the gaps. Whereas the plant genomes coming from the short read sequencing, they do not have the uniform coverage because of the issues with assemblies coming from the short read sequencing. So that's why STLFR application is introduced by the MJ. It is shown as the best application, especially for the sequencing of the long DNA molecules, including the plants, polyploid plants, and using the short read sequencing platforms. So the de novo assembly of the TQ, the scaffold N50 is more than 5.32%. And when we were using the STLFR application data for the de novo genome assembly of the human genome, we were able to get a scaffold N50 of 29 MB, which is similar to the backbone nanopore. And when we added some of the data from the nanopore to the same sample, then hybrid de novo assembly, we were able to get the scaffold N50 of 50 MB, which is better than backbone nanopore. So that's why STLFR application is the best application as a cost-effective and very fast resulting and high accuracy technology for the sequencing of polyploid plants and any animals as well. So thank you. If you have any questions, please let me know. Otherwise, you can write me an email.
So much, Ravi, for a very nice presentation. And I think discussion part we can have during the lunch time, if it is acceptable to all of us. So, is okay. So we have next presentation. Sure. Whatever.
Sorry sir, we are making so many changes, sorry. And thank you Lohia sir for bearing with us with so many changes since morning. I request Lohia sir to please felicitate Dr. Spandan and Dr. Ravi for their presentations.
Dr. Spandan, please come.
We thank you both for a wonderful presentation and also for adapting to the concession in the time. Thank you so much.
Sorry for limitation of time.
Thank you, sir. I now request Dr. Ravi to please accept the felicitation on behalf of the organizing team. Thank you. We once again thank you for being so accommodating. I now request Lohia sir to continue the session of Dr. Chandana Basu. Ma'am is already online, sir.
Online, okay. So just a great pleasure inviting Dr. Chandana. In fact, we were waiting for your presentation yesterday, which was postponed to today. So welcome, and the floor is yours. Please continue.
Thank you very much, sir. I hope I am audible.
Yes. Yes.
Are you able to see my screen?
Sure.
Yeah. So today I will be speaking about understanding the genetic basis of human hair shape, whatever lessons we have learned from mouse models. And I thank the organizers for giving me the opportunity to talk. Sorry that I wasn't being available yesterday, but they could accommodate me today. And it was great to see Thangaraj sir. In fact, my research journey started with his lab. So what's the focus of my lab and my research interest? So we all actually are quite diverse. Even sitting in the hall, there will be many people with different phenotypes. So we vary each other in how we look, how we eat, even what climatic conditions we can tolerate, what disease risks we have. And there are two terms which I would like to introduce you to, that is the genotype and the phenotype. So genotype comprises of our genetic material and phenotype comprises of the external appearance as we see of the individual. Now, most of the phenotypic diversity that we see across the world are actually importantly reflections of the adaptations that has happened in the human evolution. So my lab basically focuses on understanding the genetics of these phenotypic traits, how they differ across the populations, how we acquire them, how it influences our biological fitness, and how different selective forces actually shape them. So you can see we take evidences from maybe anthropology, from linguistics or archaeology, and then put them across just like the puzzles as you can see on this slide. So we have different phenotypic traits. We vary in our skin color, eye color, handedness, which hand we prefer to use, in height. But today we will be talking about human hair shape. And why is understanding of genetics of phenotypic traits important? It is important basically to understand, unless we understand what is contributing to our normal variation, we won't be able to understand the specifics of what is going wrong in case of diseases, and hence it is important to understand the genetics of the normal variation. So hair shape is one of the most distinct traits of our human face. It is heritable, so it's around 85 to 95%. And we can see that it varies in shape, color, texture, density, growth patterns across populations. And if we see the world hair shape diversity, according to what has been given earlier in 2007 by Lozaran, we can have different 8 categories depending on the different hair phenotypes, but broadly they can be characterized into straight, wavy, curly, and very curly or kinky. So why should we actually learn about hair genetics? This is because it will help to identify the loci which is involved in determining the hair shape. It also helps us to illustrate the biological pathways which influence in hair shape. It also helps in better understanding of the human hair disorders. It can help in contributing towards the forensic phenotyping. So, for example, if we have a case and we are trying to identify the individual, we will be able to do that with the help of these loci. Also, these are candidates of positive selection, so they can provide a lens through the evolutionary past. And most of these hair variants are actually pleiotropic, which means that they also exhibit wide-ranging effects on the human body beyond only the hair shape. So it could be that in the human evolution, it could be any other factor that is more important and it's kind of hitchhiked together with it. So it's a complex trait, and therefore it is what we already know about human hair genetics. So it's a complex trait and it's determined by more than one genes. And we have different candidate gene studies, family studies, and GWAS contributing to the our knowledge of hair genetics. Till date, we have 23 loci. Now, with genome-wide studies being prevalent with almost 15 years down the lane, you might ask why it's only small number of loci, but that's because hair shape is very difficult to measure. It's not very relatable measure like weight or height. And then we have two different genes contributing also to the similar hair phenotype. For example, we have EDR, which contributes to the straight hair in East Asians, and we have trichotillin gene, which contributes to the straight hair in Europeans. So our journey today involves PRSS53, and this gene encodes for a serine protease. So what actually led to our current study? So we have one publication from UCL group, from Adhikari et al., where there was a GWAS study that involved around a collection of about 6,000 individuals from Latin America, and then they were trying to study different traits, and they found 4 genes to be associated with hair shape. Now, EDR and TCSH was already known, but GATA3 and PRSS53 was one of 2 novel genes that they discovered. So, PRSS53 has the protease serine S1 family number 53. It's a secreted protease, and it's highly conserved in human and mice. Now we have one of the variants which is of our concern is RS111-50606, where we have a missense mutation and we have amino acid change, and this is also, it's very high in frequency in East Asians, almost selected there, and it's being positively selected there. So, and this in the paper was thought to be contributing to the straightness of the hair. So we thought to, check it out through our mice models. So all of these looked very promising for us to lead us to the track of PRSS53 journey further. So mouse models are one of the important tools to study phenotypic traits, and we have different case studies. So for example, if we have a phenotype that has been identified in a transgenic mice, and then tested in humans, then they can be found to be associated with a similar trait in humans. Or it can be that a GWAS association of a SNP to a trait in humans, and then they created humanized mice models, and then they found that this mice model mimics the same trait. However, the case 3 is the most interesting, where we create humanized mice models, but they kind of also suggest, instead of also correlating to what has been already found in humans, they also suggest some extra phenotypes which can be again further tested in humans, and the phenotype can then be confirmed in humans. So you would ask me why, how can human hair or mice hair be related? So as I said in my previous slides, we have 4 kinds of hair shapes. We have straight hair, we have baby hair, we have curly hair, and we have extremely curly hair or kinky hair, which is found mostly in African populations. In case of mice, we have 4 kinds of hair. We have the gourd and the awl, and these both are actually straight hairs, so they have no kinks. Then we have Ochin, which is has 1 bend, and then we have zigzag, which has more than 1 bend. So, or we call as kinks in terms of mice hair. So, in our study design, we actually tried to study the PRSS53 knockout as well as the edited Q30R edited variant of the mice, and we tried to study the different phenotypes and do a detailed phenotypic assessment. We were also interested in knowing the expression of this gene PRSS53 and the molecular or mechanism or the mode of action through which it acts. So you can see the 2 mice which were created through CRISPR-Cas9 technology. And so since knockout mouse was not studied, so we were interested to know how the knockout mice would look like. and we were also interested to understand more about the point mutation Q30R edited mice. And speaking about phenotypes, so we studied in detail of these two particular mouse models. We studied their hair. In the hair phenotypes, we looked at the hair thickness, we looked at the hair shape, and we looked at the hair length. In terms of skin, we looked at the skin epidermis, the dermis, and the fat layer. And we were also interested in knowing the nature of the glands. So we looked through two glands, which is the sebaceous glands and the sweat glands. It's not possible to put the results of all of these phenotypes, so I've chosen only two of them, hair shape and the skin epidermis, which are found to be significant. How did we actually do the hair shape analysis? So we kind of plucked body hair, which was plucked down to the bare skin of the mice, and we put it in the epidrauf, you can see here, and we analyzed 200 hairs for each individual mouse. And then each of these hair was either characterized with 0 kings, 1 king, or more than 2 kings, and then they were scored. So once the scoring was done, then we were interested to know, how the gross phenotype looks like. So when we saw the knockout mice, here you can see the wild type, and here you can see the knockout mice, and you can see that the homozygous mutants, we found that they had a wavy coat and the curly whiskers. Just to zoom in, you can see the curly whiskers, which was certainly a great, our moment for me in my discovery, because then we found that yes, if this gene, contributes to the straightness of the gene of the hair, human hair, then if we are doing the knockout and getting the curly whiskers, then it's certainly, showing the same trait. However, when we looked at the edited mouse, we did not observe any gross phenotype. That means that through the naked eyes, we were not able to differentiate between the wild type, heterozygous, or the mutant mice. However, when we analyzed each hair with the number of kings, then the effect was found to be significant at P8 for the P84 mice. P84 means postnatal days, which means the 84-day-old mice. But it was not significant for the P19 or the other P60, which we had, considered in our experiments. In terms of skin phenotype, we had the H&E stained back skin, and then we tried to measure, the epidermis, we tried to measure the dermis and the fat layer. And in terms of epidermal thickness, we found that the Q30R variant is associated with increased epidermal thickness in mice. We also measured the skin glands, sweat glands. So you can see here, these are basically inverted and then they were stained. And you can see here is the zoom in for each of the foot pads. We have 6 foot pads in the mice. And then we manually counted these sweat glands. So we did not find any effect in the edited mice. However, we found the effect of genotype was significant for the knockout mice to some extent. We were then interested in the expression of PRSS53, and so we did an in situ hybridization through RNA-scope, and then we found that the signals are evident in the hair follicle. Sorry. So you can see here, you can see the, here is the whisker follicle, and here you can see the signals. However, and also it is, evident in the skin epidermis, which showed that probably this is expressed in at the base of the hair follicle as well as in the epidermis, which was consistent with our results. We were then interested in the mode of action of PRSS53. So EDR, which is gene which is known to contribute to the straighter hair in East Asians through NF-kappa B signaling. So we were interested to know whether PRSS53 is actually influencing to the hair straightness using the same pathway. So we conducted a dual transluciferase assay to test if the co-transfecting PRSS53 variant Q30R with the EDR cDNA in HEK293 T cells And we were looking for basically increased NF-kappa B signal, but we found that the results were insignificant, thereby suggesting that PRSS53 might be associated with straight hair via a different pathway. That means the EDR and the PRSS53 both contribute to the hair straightness, but through different molecular pathways. So, to summarize, the effect of Q30R variant on hair shape is evident in mice, and although it's only evident in a particular age of mice, the effect of genotype on skin epidermal thickness observed in Q30R variant suggests that there are phenotypes even beyond hair shape. And since we did not observe an interaction with the EDR signaling, it suggests that PRSS53 and EDR might be operating through independent molecular pathways. I would like to acknowledge our collaborators in Roslin Institute, University of Edinburgh, and Institute of Genetics and Cancer in UK, and my funding bodies India Alliance and Marie Curie. And my learning from the mice models continues. And I will be happy to collaborate for the study of phenotypic or adaptive traits, and interested students may send their letter of interest for training or PhD. Thank you very much, and I'm open to questions.
Thank you so much, Chandnaji. It's a very interesting presentation, and specifically I understand that the ladies must have been very particular listening to her talk, because I till now I was not aware that the hairstyle and that also is inheritable, and the specifically interesting is using mice model. So compliments for a wonderful presentation, Chandnaji, and it's open for a few questions or comments, please. Yes, yes. Be precise. Huh?
Sure, sir. Hello ma'am, it was very scintillating talk. So I had just one question. So with the hair pattern and the shape that you are mentioning, are there any disease prediction outcomes?
So we have hair disorders. We have, for example, the woolly syndrome, which kind of makes your hair really, woolly. So there are different hair disorders. So with the study of, the human hair shape or the genetics contributing to the human hair shape, we are actually contributing to even to the hair disorders, because then we know the molecular mechanism or the mutations which to look at. So there are lots of hair disorders that are around there, and our study can contribute in the further years or towards the human hair disorders as well.
Thank you, ma'am.
Any other comment or question? No, I think. Yes, please.
It is an excellent talk. One suggestion that I require from you, some of the girls who are around 12 years, 14 years, hair will be there in the hands like that of the boys. So how is that they can avoid that hair, madam? You want any advice or suggestion from you?
So this is, I cannot say how they can avoid, because it's a natural trait. And again, body hair also varies from, the amount of body hair also varies from individual to individual. So some girls or even some boys at the young age may have more body hair, and that's also kind of genetic. So it's one of the traits or the natural phenomenon that happens, and it's one of the phenotypes as well.
Wonderful. I think give a big hand to Chandnaji for a very nice presentation, Chandnaji.
Thank you very much.
With this, I think we move on. Okay, please. One more question, Dr. Channa. One more question.
Yes, sure.
Hi ma'am, my name is Pralika. Can we predict our next generation can have the same disease that our fathers our ancestors are having from the hair strands, like hair syndromes? Actually, my father is having psoriatic arthritis, ma'am. So,
Yeah.
can we predict that my brother can also have the disease from that hair strands? Because my father is affected at the area of scalp, ma'am.
Yeah, so the prediction or the knowing about a risk of a disease is actually that's some of the companies actually do, like 23andMe, and you can actually give your genomes for now we have whole genome sequencing. Previously, we did not have, the sequencing costs were huge, but now with the whole genome sequencing, you can actually give your samples and then they can predict the risk of the disease. But the problem is that in the, not many of the South Asian genomes are present in the panel. So, for example, we have the 1000 genomes reference panel, but we do not have many representative of the South Asian populations there. So even if you get that, the genetic risk, or what is the risk of your brother having it, it might not be very correct, because the reference as used is based on very minimal populations and it is not representative of an entire ethnic diversity of India, as Thangraj sir was explaining. So you might be able to do that using, giving your sample for whole genome sequencing, but again, as I said, the risk score that you get might not be very accurate.
Thank you, ma'am.
Thank you so much. Very nice presentation. And in the sequence we have now Dr. Prakash to give the presentation. It's from School of Biotechnology and University of Hyderabad. Department of Biotechnology. Yes, 20 minutes or more.
I had, yeah. Yeah, good afternoon. And at the outset, let me thank Professor Kavakishore for inviting me to discuss about what we have been doing over 5 to 6 years in the past. So today I'll be talking about the genomics approach to elucidate functions of uncharacterized genes in the genome of a photosynthetic prokaryotic synchrocysts. And you can see this is transmission electron microscope picture of the synchrocysts. You have thylakoids, and where you have photosystems in there, and then they do perform oxygenic photosynthesis. To move this. Yeah. So this is the synchrocyst spaces. It's a photosynthetic, unicellular cyanobacterium. Its genome has been sequenced by Kazusa Genome Research Center in 1996, way back. And it is naturally transformable, and also targeting activation or gene manipulations are very easy. We have developed a lot of vectors for for overexpression of the genes in the system, and also for cloning large gene clusters directly into the genome is possible. So we can do also pathway engineering. We try to express and mobilize the large gene clusters directly onto the genome of these synchrocysts. So the main focus we have in the lab is gene function and regulation, especially given genetics and functional genomic approaches, and the other one is the strain development of these synchrocysts for the production of medicinally important compounds. But today I am not talking about this, but I will be focusing on only gene function regulation. So this is genome, and we have more than 50% of the genes are functionally uncharacterized. So our target is to characterize these genes. So what we do, we've taken the very well conserved genes among the cyanobacterial species, and then try to characterize them like the well conserved ones we assume to have specific roles and very important to function in the cell. And also small regulatory RNAs also, which are responding or accumulating under different abiotic stress conditions. We have chosen them also to generate and work. So I'm not going into the details of how we generate the mutants. So we generate the mutant and we have a library of the mutants, and then we try to characterize using the functional genomics approach. So we have a facility, both the linear microarray, also NGS platform in the School of Life Sciences, and we use this facility for characterize these genes. Like we use also 18 to 15K format, custom made chips for analyzing the gene expression profiling, and of course NGS workflow, and we get very good quality of RNA, and then also libraries, and then further characterize all these mutants. So this is a library of mutants we have generated in the lab, and I will explain a couple of them, but how they were, what we have discovered over a period of. So this particular protein is a negative regulator of each of genes. I will show you this. And also we have extensively worked on RNA helicase, putative RNA helicase, which is involved in energy redistribution and photosynthetic cytometry into close stress over a period of 5 years. And also we have discovered a kind of cyclic AMP receptor 13, which is involved in inorganic carbon sensing and regulation, which one of my students yesterday spoke about. And also we identified the mercury and iron transport regulators, and the mechanism was also elucidated. And also molybdenate nitrate nitrogen metabolism transcription regulator also we have worked on. And also we have discovered the heat-induced programmed cell death inside bacterial spaces, which was recently published. So, and also small RNAs, couple of small RNAs, what they do in the cell and how they post-transcription regulate the genes, we have discovered about. But I will not be going through all this. I will just take a couple of examples and discuss with you how we started elucidating the functions of these hypothetical genes or characteristic genes. So this is a library of small RNA mutants that we have generated in the lab, and which are very important in abiotic stress response, especially they regulate post-transcriptional genes that are involved in abiotic stress. So I'll take a couple of examples and I will introduce to you. First one is the programmed cell death inside a bacteria for data. So you see this, these statues and also those sculptures, and you see this brown color one. You scrape off a little bit of this and then put it in water. Then you see that there is no cyanobacteria in there. So what happens is that this cyanobacteria in the biofilms survive in a desiccated state during summer. So no water, but they survive in this biofilms and unfavorable conditions. Some cells remain viable in the desiccated state and resume growth soon after receiving the moisture from monsoon rain. So how do they survive under this extremely hot environment? That is the point. What's the mechanism by which they survive? Okay, this is the point to discuss. So these are the cells, and then upon heat shock, then they form. They are under the biofilm. So the cells are programmed to die. They are survived, and then what happens is these nutrients will be used by the other cells in this biofilm, and then when return of favorable conditions, they start growing. But what exactly the underlying mechanism is the point. So what we discovered was a novel toxin-antitoxin system which mediates heat-induced programmed cell death. So these are the two operating frames of the genes. That code for two proteins. This is this codes for an antitoxin and this codes for a toxin. But such kind of antitoxin-toxin systems are available, we well characterized in case of the strains like E. coli. But this is not at all conserved when compared to E. coli. But these two are highly similar, or homologs are found in kinds of thermophilic bacteria. So we assume that these are very important in heat stress response. So, so we generated the mutants, okay, about the toxin, the gene that code for toxin, also the gene code for antitoxin, and then characterized phenotypically. See, this is an optimal growth condition, and the moment you move this to reach 12, so 4 hours, 8 hours, or 24 hours, these bacterial cells are forming a kind of aggregates. They are coming together and bioforms kind of things. But the mutant is very stable. Even you see here, within 24 hours, almost 80% of the cells are non-viable. But in the mutant, they are really stable. Even after 24 hours of 50 degrees centigrade incubation, most of the cells are viable. This is the reason. What could be the reason why this mutant is so stable is the question. So you can see something like that in the mutant and the wild type. They form kind of biofilms or aggregates where some of the cells are dying and some are viable. But in the case of mutant, they are all very active. So we applied DNA microarrays to see the gene, what kind of expression profiles and what genes that are upregulated. You can see some of the heat shock proteins are upregulated, some filling genes are upregulated, some CRISPR-Cas genes are also upregulated because of the mutation in this. See. So there are 2 genes, okay? This codes for a toxin protein, this codes for an antitoxin protein. We ask the question, what is the role of this antitoxin? So whether these 2 interact with each other or not. Especially, at least in other strains, it is known that toxin function is masked by the antitoxin. When it is really required, this antitoxin releases from the toxin, and then the toxin executes its function by degrading the RNA or other cellular components. So just we want to see whether these 2 interact with each other or not. Now you can see that this is a bacterial 2 hybrid system, where you can see this is a positive control and negative control, and then this pink color developed. These 2 proteins are very strongly associated. They are interacting with each other. And also one of this in the dystonic of run, when you mutate the first gene, the second gene also not expressing. They are expressing, co-expressing. And when you tag the first protein, one protein, and then elute, the second protein is also coming with it. So the point is here. So you can see this, the toxin, it has, isolated point of 8.8 in the basic, and the other one is 4.2, is the, acidic condition. So probably these are electrostatic interactions, and then we model these proteins and then looked at these big charges. So they are very strongly associated because of the electrostatic interactions, and we identified that. And then, of course, what is gel exclusion chromatography indicator? This is a multivariate complex involving about 16 proteins, and one protein with the tag eluted also the second one. But we see a lot of degradation products, and then we identified what these products are. They're nothing but this antitoxin degradation products. So the toxin is very stable. Antitoxin is labile, and it is degraded by proteases probably. And then, so what's the situation in the case of this cyanobacterial programmed cell death under especially heat condition? We assume that at optimal condition, optimal temperature, both are expressed, and then the antitoxin masks the function of the toxin. But at high temperature, what happens? Probably this antitoxin releases from the toxin, and then toxin induces this programmed cell death. Then, so we tested also their association constant, and you can see that at a high temperature, this association is minimized. The toxin and antitoxin association is reduced. And we also wanted to see that this dissociation, or the reduced association, is not due to their denaturation at high temperature. And differential scanning calorimetry experiments were performed. So their temperature dependent dissociation is not due to their unfolding. They are intact, but they are separated at high temperature. So, and then we checked this, it's a big endoribonuclease. We wanted to test the genes that are upregulated because of its mutation, whether it degrades such RNA molecules or not. You can see here, when you add the toxin, the RNA is degraded. In presence of antitoxin, RNA is not at all degraded, and in presence of antitoxin and toxin both, also it's not degraded. Only toxin degrading the RNA molecule. And at high temperature also, you can see even at 50 degrees centigrade, the toxin degrades the RNA. And even antitoxin is not able to associate with the toxin. That's the reason you see the degradation products. Even at 60 degrees centigrade, toxin is very stable, degrading RNA even in its presence of antitoxin. It does mean that antitoxin is not binding to the toxin, and then toxin is degrading this RNA and inducing the programmed cell death. So this is the bioanalyzer RNA quality check. This is the green number, RNA integrity number. You can see in the wild type, the moment the cells from optimal growth conditions, you can see all these three regular RNA, and the moment you shift them to high temperature, you see the degradation of RNA, total RNA. But the mutant, very stable RNA, even after 8 hours, at 50 degrees centigrade, you see the RNA is very stable. That means very clear this antitoxin is, not be associated with the toxin, and the toxin is degrading the RNA, thereby inducing the programmed cell death at high temperatures. So this is a model of these genes are expressed and then they are associated together. But the high temperature condition, their association is reduced and the toxin is degrading the RNA molecule, thereby inducing the programmed cell death. So this is what it is. So the mechanism, so you see the statues and all, the brown color on the atom, they are cytobacteria and those biofilms. But high temperature, still they are surviving the biofilms, and some are persistent cells, some are, some cells are programmed to die because of this antitoxin system. And then what happens is these provide the nutrients under these bioforms, and then when return of favorable condition, they are able to survive. So this is one of the example. We use the reverse genetics and functional genomic approaches to identify the functions of our vertical. There are so many such examples from our laboratory, but I will restrict to one more example of inorganic carbon sensing mechanism. See, this is the photosynthetic operators in cyanobacteria, like higher plants. You have photosystem 2, photosystem 1, cytochrome B6F complex, and then, of course, the Calvin-Benson cycle where, water is split into oxygen and protons, and this electron is extracted and then flow to Calvin-Benson, in a DPH, and then this is used in Calvin-Benson cycle. The carbon dioxide is fixed in this Calvin-Benson cycle, and all of you know about it, I'm sure. The point is that this carbon dioxide is the point. So this cyanobacteria evolved over a period of time, several millions of years ago, the carbon concentrating mechanism. They can have two sources of carbon, inorganic carbon. One can be carbon dioxide, other one can be bicarbonate. But they don't prefer to take this bicarbonate, but they prefer to take carbon dioxide because it is easily diffusible to the membrane. The bicarbonate, it is, the transporters, they are ATP dependent. They have to spend energy, so that they don't want to use the bicarbonate, but they use the carbon dioxide to take in. So there are so many bicarbonate transporters, but they are not activated. The genes that code for this bicarbonate are not activated as long as carbon dioxide is available to the cell. The moment they see that there is no carbon dioxide, then trigger the expression of these genes, and then bicarbonate is in. So these are those genes. Then, so low carbon dioxide response genes in Synechocystis or cyanobacteria, you see the moment you shift them to low carbon dioxide, the bicarbonate transport systems are very active, they are upregulated. So, but what is the signal by which inorganic carbon levels are sensed and transduced to trigger the carbon concentrating mechanism? how they sense whether the carbon dioxide is available or bicarbonate is available, which one to be preferred to take in, whether to carbon dioxide or the bicarbonate, what is the signal, how they sense this signal, carbon dioxide. So we show you, today I will show you it's a kind of CRP or cyclic AMP receptor protein, binding protein, and everybody know about the Jacob von Monod's story about lack of brown. Okay, so this is something different from the cyanobacteria. We have at N-terminal is an extra peptide. This is not like E. coli CRP, cyclic AMP binding receptor protein. So we generated the mutant of this one. Okay, and then I don't want to discuss about the details of it. We generated the mutant and then worked with this one and applied, of course, the microarray analysis. You can see here that when you inactivate this CRP, okay, cyclic AMP receptor protein, you see the upregulation of all the bicarbonate or the CCM genes, carbon concentrating mechanism genes in the microarray. It's very clearly upregulated, and also we confirmed by real-time PCR analysis. An interesting point is that, when we checked where it is localized in the membrane, not in the cytoplasm. This is the first report, this kind of CRP proteins associated with the membrane. No other species they are associated with the membrane, but we do not know why it is associated with the membrane. And the moment you add cyclic AMP, they are, so in case of when there is no cyclic AMP, it is still in the membrane, but the moment you add cyclic AMP, they are released into cytoplasm. That means upon binding to the cytoplasm, the cyclic AMP, it's coming out, coming into the cytoplasm very clearly. And also immunogold labeling clearly demonstrated they are localizing in the peripheral regional membrane. Someone previously reported that adenylyzed cyclase, which converts ATP to cyclic AMP, is activated by carbon dioxide. So then we wanted to test, is it something like excess carbon dioxide availability, and that carbon dioxide triggers the adenylyzed cyclase so that it converts the ATP into cyclic AMP. And then the cyclic AMP binds to the membrane-associated protein, CRP, and then releases into cytoplasm and then regulate the expression of the genes. So this N-terminal peptide is also probably we guess that it is the reason responsible for its association to the membrane. And we tested this physiology and also photosynthetic activity, bicarbonate-dependent photosynthetic activity, that at a lower carbon conditions, so the Vmax is more. That photosynthetic performance is more in wild type, but not in the mutant. It's reduced. And also number of carboxysomes which are responsible for fixing the carbon dioxide within there is also lower, and a low carbon dioxide condition in the mutant. And then so we wanted to see whether this IRP is regulating the CCM genes or not. Upon binding to cyclic AMP under high carbon high carbon dioxide levels are low, then we, because there are so many different kind of computational biology researchers, they have reported that it's the CRP as a targets of different kind of carbon concentrating mechanism genes. And also we tested this cyclic AMP. Okay, it binds to the CRP1 protein, but not cyclic GMP is not the signaling molecule. That also we modeled and analyzed. And is now currently one of my students is trying to look at the structure of this in presence of cyclic AMP and also target DNA molecules. So this is a model where you can see that at a high carbon dioxide condition, the carbon dioxide triggers the adenylyzed cyclase, and then ATP is converted to cyclic AMP, and then cyclic AMP upon binding to the CRP, it releases into the cytoplasm and then regulate the carbon concentrating mechanism. This is a kind of first report how the carbon dioxide levels or inorganic carbon levels are sensed by the cyanobacterial cells. There's many more examples, but to discuss, but I don't have time to discuss about all these things. I just in summary, I want to conclude that we use this reverse genetics and functional genomic approaches to elucidate functions of the genes in the genome of cyanobacteria. I'm telling you, even till now, only 70% of the genes in the E. coli genome, we know what they do, but 30% of the genes we do not know what they do. In case of cyanobacteria species, 50% of the genes, so out of 3,000 genes we know the functions of our 1,500 genes, what they do, but rest of them we do not. They are all hypothetical or uncharacterized genes. So understanding their functions is very important. That is what we have been trying to do. Not only that, the post-transcriptional regulation by small regulatory RNA molecules, that's going on in the laboratory. Thank you very much for your time and questions.
Thank you so much, Dr. Prakash, for an interesting presentation. Yeah, please. Mike.
Mike and not You have talked about mutants which are thermostable and some of them are not. Now, how do you identify mutant which is going to be thermostable? Which will be thermostable?
No, actually it is not like that. So we are picking up the genes that are conserved among cyanobacterial species. So when they are conserved, it means that they have some important functions. And then when we picked up such genes and then tried to inactivate them, okay, a couple of them we saw that they are conserved with the thermophilic bacteria, not only cyanobacteria, other species thermophilic. That's the reason we assumed that they may be important for thermal adaptation, then proceeded, especially this toxin antitoxin system. That is how we discovered heat-induced programs are there. So under heat, see for example, you have a lot of sculptures and also statues there. You see the brown patches in temple towers and all. They're all cyanobacterial species. You scrape off a little bit and put it in water and you see the cyanobacteria growing there. But under hot temperature and high temperature, how they are surviving, that's the point. So the mechanism we identify, this toxin antitoxin system is responsible for such kind of induce the programmed cell death of certain cells in that particular bioform, so that the persistent cells, the cells that exist, remain to survive. They will take up these nutrients and survive over a period of time, and then when again rainy season comes, they come back. So not all are stress responsive. Okay, this particular case I'm talking about because they are very conserved with thermophilic bacterial species. These homologs are conserved with thermophilic bacterial species.
Yes, please. Sir, all prokaryotes during adverse environmental conditions, they undergo encystment. Is it not that type of capacity for the cyanobacteria?
What is that?
Encystment.
Okay.
During adverse environmental conditions.
Yeah.
So that protects them from all this type of the programmed cell death everything. So does this species not having the existence?
No, the point is, the point is that they form these biofilms and try to survive under this environment. But they need nutrients, right? So there are some kind of extracellular death factors which are not discussed about it. They are responsible, it's a kind of parent sensing mechanism, so they selectively degrade, kill some of the cells. They undergo suicide. They undergo cell death. The nutrients are required for the remaining cells, so they will keep up, maintain. And then the moment, favorable conditions come back, they survive.
Usually encystment is longer dormant.
Yeah, so that's this kind of time. Yeah.
Thank you so much.
Thank you very much.
Very useful. Thank you so much.
Thank you so much, Prakasha, for a wonderful session. I now request Lohia sir to felicitate our speaker, Professor JSS Prakash sir.
They have a system. I also said Renado, but they will like it. This is
Waladi sir from Flame University, Pune. Sir has given a pre-conference workshop on machine learning for biologists. Lohia sir, please. Felicitate Jayaraman sir too. Thank you, sir. I will be miserably failing in my duty if I don't extend my special gratitude and thanks to Lohia, sir. He's already been felicitated for his session, but I think special appreciation, sir. Sir, session just started for 1 hour in the morning, 8:30 to 10. He was supposed to chair, but he continued, and thank you, sir. Thank you so much for being patiently conducting it. Thank you. A few important announcements for the participants. We will now break for lunch. And after that, please continue the poster viewing part of